Hello everybody, how are you people? I am back again with a very new session of our ongoing crash course and today's topic very interesting KTG and thermodynamics. So जल्दी से जल्दी अब जितने लोग हो यार आप लोग come over here, जल्दी मुझे चैट में बताओ if I am visible and audible to all of you and हम बहुत ही जल्दी सेशन स्टार्ट करने वाले हैं. सो क्विकली जल्दी, टाइम नहीं है हमारे पास. आज मैं आप लोगों को एक बहुत अच्छी इंटरेस्टिंग चीज़ बताने वाला हूँ. हमारी ऐप पे सारे टेस्ट्स लाइव हो चुके हैं. सो आपको बस कोड यूज़ करना है एंड यू कैन अवेल द बेनिफिट्स ऑफ गिविंग दोज टेस्ट. साथ ही साथ एनालिसिस रिपोर्ट एंड व्हाट नॉट. सो आई विल बी जस्ट गिविंग यू अ ग्लिम्स वो टेस्ट कैसे आप एक्सेस कर सकते हो. साथ ही साथ आपका इंटरफेस भी कैसा है, मैं सबके बारे में बात करूँगा. बट जस्ट डू मी अ फेवर, टेल मी कि यार आप लोग कितने लोग प्रेजेंट हो. ओके एंड जिससे कि हम सेशन बहुत जल्दी स्टार्ट कर पाएँ. बहुत ही अच्छा अमेजिंग सेशन होने वाला है थर्मोडायनेमिक्स का. थर्मोडायनेमिक्स की बात करूं तो आप लोग केमिस्ट्री का अगर आपने क्रैश कोर्स अटेंड किया है थर्मोडायनेमिक्स का तो आप काफ़ी रिलेट कर पाओगे. एंड जो मिसिंग पॉइंट्स थे वहाँ पे जहाँ पे फिजिक्स डायल इन हो रही थी, we'll be discussing about those key points as well, and I'll be telling you also how actually you can understand thermodynamics and physics. Physics में thermodynamics के क्या concept आते हैं, ठीक है. So बहुत ही जल्द हम सेशन स्टार्ट करने वाले हैं. हेलो अर्पित, हेलो अभिषेक, हाय अर्नव, हाउ आर यू पीपल? Okay, so let me give you a brief about myself. My name is Adarsh Rai and I am a graduate from NIT Bhopal. I have been mentoring students from past 6 years to crack that JEE and NEET exam. Okay, and I have a very good record. And if I talk about Extramarks as well, so Extramarks ने भी बहुत हद तक स्टूडेंट्स की ये श्योरिटी क्रिएट की है कि वो जेई में बहुत अच्छी रैंक ला पाएँ. एंड अगर अभी के रिकॉर्ड की बात करें तो आउट ऑफ एवरी 7 स्टूडेंट वी हैव अ रिकॉर्ड जिसमें से 1 हैज़ बीन सेलेक्टेड इन जेई मेन एंड प्रेजेंटली ही माइट बी स्टडिंग ऑल्सो. ओके, एंड इफ़ आई टॉक अबाउट द ऐप, सो ऐप पे जो आप लोगों के लिए कंटेंट है, सो यार वो ऐसे इधर उधर का नॉट अ रैंडम कंटेंट, दैट इज इट हैज़ बीन स्पेशली डिज़ाइंड एंड क्यूरेटेड एज पर NTAs. जो भी उनका जो सिलेबस क्रिएट हुआ है एंड जो भी प्रीवियस ईयर क्वेश्चंस आ रहे हैं एंड फ्यूचर में किस पैटर्न, किस टॉपिक, किस सब टॉपिक से मैक्सिमम क्वेश्चंस आने की प्रोबेबिलिटी है, उन सारी चीज़ों को ध्यान में रखते हुए वो पूरी की पूरी ऐप एंड उसके क्वेश्चंस डिज़ाइन किए गए हैं. सो डू गिव इट अ वॉच. आपको डेफिनेटली उन क्वेश्चंस को ट्राई करना चाहिए एंड इट कैन एक्चुअली बी अ बूस्ट टू योर एग्जिस्टिंग स्टडीज. ठीक है. हाय देवेंद्र, हाउ आर यू? सो यस, सो दिस वॉज द ऐप आई वॉज टेलिंग यू अबाउट. एंड मैं आपको ऐप के एक फीचर अभी जस्ट बताने वाला हूँ. उससे पहले मैं आपको एक इंपॉर्टेंट न्यूज़ दे दूँ कि जितने भी आपके क्रैश कोर्स हुए हैं पर सेशन आपको एक टेस्ट हमारी तरफ से फ्री ऑफ कॉस्ट असाइन हुआ है. ठीक है. सो व्हाट यू नीड टू डू, आपको ऐप डाउनलोड करनी है. डिस्क्रिप्शन में जाके उसमें आपको लिंक मिल जाएगी ऐप की. आप डाउनलोड करो उसको. दोनों ही प्ले स्टोर पे भी है एंड ऐप स्टोर पे भी है. आप उसे डाउनलोड करो, ओपन करो एंड वहाँ पे कैसे आप उस कोड को यूज़ करके वो ओपन टेस्ट का एक फीचर एक्सेस कर सकते हो. आई विल बी जस्ट शोइंग यू पीपल. एंड ऐप पे भी आप बहुत सारे क्वेश्चन सॉल्व कर सकते हो यार, फ्रॉम विच एवर टॉपिक यू लाइक. अपार्ट फ्रॉम दैट यू कैन ऑल्सो क्रिएट योर ओन टेस्ट in whichever way you want. There are also score booster tests, then there are these rank booster test as well. और उसके बाद साथ ही साथ आपके ये ट्रेंडिंग टेस्ट भी चलेंगे जो कि बहुत सारे लोग दे रहे हैं. एंड इन टेस्ट को देने से आपको ये पता चलेगा कि एक्चुअली वहाँ पे ऑन अ नेशनल बेसिस आपकी रैंक क्या है. यहाँ पे आपकी प्रॉपरली रैंक बताई जाएगी. एक बहुत ही अच्छी एनालिसिस रिपोर्ट क्रिएट होती है जो आपको बहुत अच्छा इंसाइट देगी आपके टेस्ट देने में. व्हाट हैज़ बीन योर की पॉइंट्स, व्हाट हैज़ बीन योर वीक एरियाज, वीक पॉइंट्स क्या सब थे, सबके बारे में बहुत ही अच्छा एनालिसिस रहेगा. ठीक है. अब ये रहे वो कोड्स. तो देखो, काइनेमैटिक्स का जो सेशन था, काइनेमैटिक्स का क्रैश कोर्स जो आप लोगों ने अटेंड किया है और जिन्होंने नहीं किया है, डू वॉच इट. आप काइनेमैटिक्स का सेशन देखो एंड उसके बाद आपको टेस्ट देना है. एंड टेस्ट का जो कूपन है ये लिखा हुआ है. सो स्क्रीन को फ्रीज करो और आप बहुत जल्दी ये टेस्ट के कूपन्स जो हैं लिख लो, पेन डाउन कर लो. ऐसे ही लॉज ऑफ मोशन का वो कूपन है. देन वर्क पर एनर्जी, रोटेशनल, KTG काइनेटिक थ्योरी ऑफ गैसेस एंड थर्मोडायनेमिक्स का ये कूपन है. सो यू हैव टू जस्ट एंटर दीज कोड्स इन द ऐप इन द ओपन टेस्ट सेक्शन. एंड आज की अगर सेशन की बात करूं मैं, जो आज का सेशन है KTG और थर्मोडायनेमिक्स का, सो उसका कूपन ये है. एंटायर थ्रू आउट द लेक्चर आपको प्रॉम्प्ट होता रहेगा जिससे कि आप इसको कॉपी करके वहां पे यूज कर सके. एंड कहाँ कॉपी करना है, जस्ट लेट मी गिव यू अ लुक अबाउट इट. सो अगर मैं आपकी बात करूं ऐप की, देखो ये रहा आपका ऐप का इंटरफेस, ठीक है, ये आपका ऐप का इंटरफेस है। आपको सबसे पहले तो ऐप डाउनलोड करनी है। ऐप डाउनलोड करने के बाद आपको अपनी प्रोफाइल क्रिएट करनी पड़ेगी एंड प्रोफाइल का जो पेज है कुछ इस तरीके का होगा, ठीक है। क्रिएट प्रोफाइल में आपको यहाँ जेई में जाना है ऑब्वियसली, बिकॉज ये जेई का क्रैश कोर्स है। जेई इंस्टीट्यूट पे जाना है, देन उसके बाद आपको क्लास 12 प्लस पे जाना है, बिकॉज ये क्रैश कोर्स है ड्रॉपर्स के लिए, जिसमें 11 12 दोनों के कॉन्सेप्ट्स है। बायलिंगुअल, बिकॉज इट्स इन बायलिंगुअल। देन स्टार्ट डेट ऑब्वियसली हमारी 3 जनवरी है, जो आपको फर्स्ट लेक्चर जो मिलेगा वो 3 जनवरी से मिलेगा। जैसे ही आप नेक्स्ट पे जाओगे, यहाँ पे आपकी डिटेल्स रहेंगी, इंग्लिश मीडियम वट एवर इट इज, जस्ट फिल देम अप और उसके बाद आप सेव कर देना। आप जैसे ही सेव करोगे आपकी एक प्रोफाइल क्रिएट हो जाएगी क्लास 12 प्लस में आपके नाम से, ठीक है। इनकी प्रोफाइल ऑलरेडी क्रिएट हो चुकी है, सो आपकी जैसी प्रोफाइल क्रिएट होगी आप इस पेज पे लैंड कर जाओगे, ठीक है। आप इस जैसे ही पेज पे लैंड करोगे, देन आफ्टर दैट आपको क्या करना, आपको ये ओपन टेस्ट में जाना है एंड जो टेस्ट आईडी मैंने आपको बताई ना वो यहाँ पे मेंशन करना है, ठीक है। यहाँ पे जैसे ही टेस्ट आईडी मेंशन करोगे और नेक्स्ट करोगे, आपको एक इनविटेशन पेज आ जाएगा जहाँ पे आपको सारे इंस्ट्रक्शंस रहेंगे कि क्वेश्चन कैसे अटेम्प्ट करना है, क्वेश्चन का टाइम कितना रहेगा, कितने क्वेश्चंस है, प्लस माइनस एवरीथिंग, ठीक है। आप वो क्वेश्चंस ट्राई करते जो आपका टाइमर जैसे ही आप ऑन ओपन करोगे उस चीज को स्टार्ट टेस्ट करोगे, आपका टाइमर ऑन हो जाएगा एंड टाइमर ऑन होता जाएगा। फिर तो आपको टेस्ट देना है, आपको पता करना है आपकी स्किल कितनी है, आपकी नॉलेज कितनी है। एंड उसके बाद सबसे मजे की बात क्या है, द बेस्ट फीचर इज दिस एनालिसिस रिपोर्ट, this analysis report. So at the end of the test, when you are finished up with giving the test and you just press that button finish the test, then you will be given this scorecard. ओके, एंड यहाँ पे आपको स्कोर कार्ड पता चलेगा, देन आपको परसेंटाइल पता चलेंगे। परसेंटाइल इज अ वेरी यूनिक थिंग, और जो कि आजकल जेई एनटीए क्या करता है, परसेंटाइल ही तो रिलीज करता है आप लोगों के। सो परसेंटाइल आर नॉट परसेंटेजेस, दे आर एक्चुअली टेलिंग यू कि आप कितने लोगों से आगे हो। ओके, सो यहाँ पे 50% परसेंटाइल है स्टूडेंट की, तो ये 50% से आगे, सो ही नीड्स टू इम्प्रूव अ लॉट। देन उसके बाद नो योर एफिशिएंसी, आपको ये सारी चीज़ें पता चलेंगी। टोटल टेस्ट आपने कितनी देर में दिया, इस स्टूडेंट ने बस 16 सेकंड में वो टेस्ट दे दिया, तो इसलिए ऑब्वियसली इसकी परसेंटाइल बहुत कम है। देन यहाँ पे आपके कितने क्वेश्चंस करेक्ट हैं, कितने इनकरेक्ट हैं, बहुत ही अच्छा एक एनालिसिस रिपोर्ट मिलेगा। इवन ये चीज बहुत इंपॉर्टेंट है, कहां पे यू जस्ट हैप्पीली अटेम्प्टेड द क्वेश्चन, जो कि रिक्वायर्ड नहीं था, आपको उतना जल्दी नहीं जाना था, और टू फास्ट, आइडियल और ओवर टाइम, आपने कहा बहुत ज्यादा टाइम लिया है। ये सबसे इंपॉर्टेंट फीचर है ओवर टाइम का, ठीक है, कि आपको ओवर टाइम कहा आपने बहुत ज्यादा ही टाइम दे दिया, इट वॉजंट रिक्वायर्ड। Either if you are going with the wrong approach, then only it is taking overtime. Yeah, you need to practice more on that topic, right? Then इन सारी चीज़ों के बाद आइडेंटिफाई योर स्ट्रॉन्ग एंड वीक एरियाज, इंप्रूवमेंट एरियाज, मोशन इन 1D 2D, ये तक आपको बताएगी एनालिसिस रिपोर्ट कि आपको कौन कौन से टॉपिक्स में फोकस करने की ज़रूरत है, ठीक है। सो आई सपोज यू हैव अंडरस्टूड ऑल दीज थिंग्स, एंड यहाँ पे डिफिकल्टी वाइज क्वेश्चंस कैसे थे, इजी क्वेश्चंस आपने कितने अच्छे किए, देन मीडियम रेंज के कितने किए, डिफिकल्ट के कितने किए, एवरीथिंग व्हाट अ स्टूडेंट नीड्स such that he can actually know his present status, whether he is in a good line और वो सही से perform कर रहा है नहीं कर रहा है, और he is just doing as per has been told to him by so many experts, but the result is not in sync with that. So आपको एक देखो क्लियर पिक्चर बहुत ज़रूरी है, आईना सबको मिलना चाहिए। There should always be a mirror. Even I use a mirror जिसमें मैं देख पाऊँ, मुझे भी चाहिए कि मैं देख पाऊँ मैं क्या सही और क्या गलत कर रहा हूँ। So that is very eminent in any student's life, and this analysis report is all about that. It can actually point you out those weak areas जो कि आपको पता तक नहीं है, डिटेक्ट तक नहीं कर पा रहे हो, ठीक है। एंड ये पूरा फीचर इट इज फ्री ऑफ कॉस्ट, इट इज फ्री ऑफ कॉस्ट। जस्ट यू व्हाट हैव टू डू इज, वहां से आपको कोड लेना है, यहाँ पे टाइप करना है, टैप करना है, एंड जैसे ही आप टैप कर दोगे आपका टेस्ट ओपन हो जाएगा। सो बहुत ही अच्छी तरीके से क्रैश कोर्स को सुनो, अपने पुराने जितने भी कॉन्सेप्ट्स उनको मेमोराइज करो और ये टेस्ट फीचर को ऑप्ट करो, इट इज़ वेरी इंपॉर्टेंट, ठीक है। हम वापस सेशन पे आते हैं एंड सेशन स्टार्ट करने वाले हैं। हाय रक्तिम, हाउ आर यू, गुड इवनिंग एवरीवन, गुड इवनिंग अर्पित। सो एज आई टोल्ड यू, ये सारे आपके कूपन कोड्स हैं, इनको आपको यूज़ करना है। सो इस क्रैश कोर्स के बाद भी इस कूपन को यूज़ करना एंड टेस्ट देना। आई एक्चुअली वॉन्ट टू सी आप लोग कितना अच्छा परफॉर्म कर रहे हो, एंड इवन यू शुड नो how well you are performing. Okay, so let's start with the session, and initially पूरा session जो रहेगा it will be a combination of two units, that is kinetic theory of gases, and the later portion will be about thermodynamics. So thermodynamics will actually be covering around 75 to 80% of this lecture, and 20-25% will be dedicated to KTG. So in KTG we just need to memorize few things, few concepts. You just need to understand basically how gases actually behave, how molecules in gases are moving, and what all things, what all physical quantities are related with gases, which we should keep in mind, which are actually necessary, because the concepts of kinetic theory of gases are actually very relevant whenever I am about to study thermodynamics. Thermodynamics में वो specific heat capacity at constant pressure, constant volume, वो change in internal energy, सारी ही चीज़ें यूज़ होती हैं. एंड ये कहाँ से आती हैं? ये सारी की सारी चीज़ें KTG से ही समझ में आती हैं. So we need to understand this kinetic theory of gases. What is this model all about? Okay. So let's first begin with Avogadro's hypothesis, and it's a very common thing in physics, in chemistry also you all must have studied. So it just says that at fixed temperature and pressure, the number of molecules per unit volume is same for all gases. That's very true. And one more thing, the number of molecules in exactly 22.4 liters of any gas is actually equal to the Avogadro number. And what is Avogadro number? So Avogadro number is 6.023 into 10 raised to the power 23. It's a very, very famous figure, and I suppose all of you must be knowing about it. So this is that Avogadro hypothesis कि 22.4 liter of any gas will have these many amount of molecules residing inside it. Okay, and यहाँ से फिर number of moles का भी concept आ जाता है कि 1 मोल मीन्स इतने लीटर गैस, इतने नंबर ऑफ मॉलिक्यूल्स. सो वहाँ से एक नंबर ऑफ मोल्स का भी फीचर आ जाता है कि नंबर ऑफ मोल्स एक एमिनेंट क्वांटिटी हो जाती है जो कि किसी भी गैस के लिए जिसमें मॉलिक्यूल्स हैं डिफाइन करना बहुत ज़रूरी हो जाता है, काफ़ी ज़्यादा आसानी हो जाती है. जैसे मैंने जो आपको प्रेशर के बारे में बताया था कि प्रेशर इसलिए आया बिकॉज फ्लूइड्स में वो फोर्स वो रोल प्ले नहीं कर पा रहा था जिससे कंप्लीट सेटिस्फैक्शन मिले. बहुत सारे ऐसे इवेंट्स थे जो कि फोर्स ढंग से एक्सप्लेन नहीं कर पा रहा था. दैट इज द रीज़न प्रेशर को हमने एक फिजिकल क्वांटिटी क्रिएट किया दैट कैन बी एक्सप्रेस्ड अपॉन फोर्स बाय एरिया. सो दैट इज द रीजन हमने नंबर ऑफ मोल्स को भी डिफाइन किया, एंड इट इज इंस्टेड a fundamental quantity. If you remember, among those 7 fundamental quantities, number of moles is one of them. And what is number of moles? It is the total number of molecules which a gas has divided by the Avogadro number, that is 6.023 into 10 raised to the power 23. This will actually give you the number of moles present in that gas. Also there is one more formula. Suppose you are not given with the number of molecules obviously, and you are given with the mass of that gas. So the mass of the gas, let's say it is m, okay, and the molecular weight of this gas is suppose m with a subscript w. This is what molecular weight, and molecular weight you all must be knowing. ठीक है, जो atomic mass होता है. So m divided molecular weight भी आपको number of moles ही देगा. ठीक है. So I suppose you have been dealt with all these things, and obviously ideal gas, very important ideal gas equation. क्या होती है ideal gas? The gases जो कि कभी ideal होती नहीं है, but conditions create की जा सकती हैं जिससे gases, normal gases भी अपने ideal nature की तरफ behave करें. और क्या होती हैं conditions? So at low temperature or high, okay, at low or high temperature the interaction between molecules of a gas becomes negligible. So it is not low temperature, it is actually, this is right, at low pressure. ठीक है. So at low pressure or high temperature the interaction between the molecules of gases becomes negligible and gas behaves just like an ideal gas. So इन दोनों conditions को create करके आप gas से एक ideal nature expect कर सकते हो. ठीक है. And जो ideal gas की equation है that is what? It is PV is equal to nRT. So ये equation काफ़ी important है, इस equation को आप हमेशा याद रखना. ठीक है. PV is equal to nRT, जहाँ पे P is pressure, V is volume, N is number of moles, R is what? It is universal gas constant, that is 8.314 joule per mole Kelvin. And obviously number of moles को मैं m upon molecular weight consider कर सकता हूँ, और small n को total number of molecules divided by Avogadro number भी कर सकता हूँ. तो I suppose all of you must be knowing about the real ideal gas equation, that is PV is equal to nRT. Real gas equation इससे थोड़ी altered रहती है, and हमें अभी real gas equation में उतना ज़्यादा infuse होने की ज़रूरत नहीं, क्योंकि maximum question जो हम experience करेंगे those will be around this ideal gas only. ठीक है. अब अगर मैं KTG जो थ्योरी है उसके कुछ अजम्पशंस क्रिएट हुए हैं, ठीक है, कि ये अजम्पशंस पे ही हम ये KTG की थ्योरी को स्टडी कर सकते हैं या उससे जो भी एक इंपॉर्टेंट एलिमेंट्स है डिकोड कर सकते हैं. तो थ्योरी के इन अजम्पशंस पे वी नीड टू नो देम, राइट. सो व्हाट आर दोज थ्योरीज, व्हाट आर दोज अजम्पशंस? सो फर्स्ट वन इज दैट ऑल गैसेज आर मेड ऑफ मॉलिक्यूल्स रैंडमली मूविंग इन ऑल डायरेक्शंस. So gases molecules से बनी हैं, that's we all know, and those molecules are not moving in a defined path. They can move haphazardly in any direction. Okay. Then the size of molecules is obviously very small as compared to the average separation between them. So molecules are of a particular size, but the separation between molecules is obviously much larger than their individual sizes or individual diameters. Then molecules exert no force on each other or on the walls. So molecules force नहीं लगा रहे, but how is that possible? Molecules are obviously colliding with each other and they are exerting force. So this is an assumption which has been made and we cannot do anything with that. So molecules obeys Newton's laws of motion and obviously अगर यहाँ से force लग रहा है तो उल्टा ही force दूसरा molecule भी लगाएगा whenever they are actually colliding. जब भी collision हो रहा है तो force लगेगा. And ये जो आप बात कर रहे थे each other और wall पे, ये net force की actually बात थी कि walls जो हैं उस पे जो net force रहेगा वो obviously zero के बराबर रहेगा जितनी walls है. But this is not true, but we actually assume it to be. All collisions between a molecule are always elastic. This is very very important because अगर वो elastic नहीं होंगे तो collisions तो हो ही रहे हैं. Collisions are occurring every second. Every second the air which is around you, the molecules of it are also colliding with each other, and if they are not elastic, collisions are not elastic, then what will happen? Energy loss will occur. Energy loss होगा और energy loss होने से क्या हो जाएगा? Energy loss होने से molecules की energy कम होती जाएगी, so movement ही बंद कर देंगे. So obviously their collisions are elastic. Okay. Now let's talk about the pressure. So what is actually the pressure exerted by a gas? So pressure के लिए we have a very good formula and that is 1/3 times total mass upon total volume into individual velocities. देखो अब molecules हैं, so molecules की individually हर molecule की एक अलग velocity है. So आप ऐसे हर एक molecule की velocity थोड़ी note down करोगे. You cannot note down the velocities of each and every molecule, right? And just take the average out of it. So एक exact figure जो इस pressure को define करता है, मतलब what has been done कि we have taken a method and calculated actually the average amount of velocity of each molecule, which say suppose there are n number of molecules having individually v1, v2, v3, v4 and so many velocities, and we took out the average of that, and based on their average we calculated this value of pressure, but it was nowhere near to the pressure actually exerted by that gas. So then we found a value, then we found a velocity's value that actually was justifying this pressure's value, and this velocity which we actually found out was actually the RMS velocity. So RMS velocity बहुत ज़्यादा ही एक important figure होता है, and ये RMS का concept आपको alternating voltage में भी बहुत clearly समझ में आएगा कि power calculation में भी कैसे आपका RMS current और RMS voltage ही काम आता है. So over here as well जो भी velocity आप use करोगे उसकी RMS value ही pressure को exact तरीके से define करेगी. ठीक है. So pressure is this figure which you are noticing over here. ये क्या है? ये RMS velocity का actually whole square है. ठीक है, as is written over here. और RMS velocity क्या होती है? What is RMS velocity? So RMS velocity का it's goes in the backward direction कि पहले आप individual velocity से suppose I want to find the RMS velocity of 2 to 3 velocities, say suppose V1, V2 and V3. So what will be the approach over there? First I'll be squaring them up. So it will become V1 square, then V2 square, then V3 square. Then I will taking out the mean of that. So mean निकालने के लिए मैं तीनों को add करूँगा और divide by 3 कर दूंगा, and फिर बाद में उसका अंडर रूट ले लूंगा, तो ये चीज़ मुझे क्या दे देगी? RMS velocity. So यहाँ पे भी तो वही हुआ है, यहाँ पे भी तो देखो वही हुआ है. आपने पहले सबका स्क्वायर किया, फिर बाद में उनका मीन ले लिया और फिर अंडर रूट नहीं लिया, तो अंडर रूट नहीं लिया तो VRMS का होल स्क्वायर हो जाएगी, और अगर अंडर रूट ले लेते तो VRMS होती, राइट. सो ये जो आप फिगर देख रहे हो इसको हम इजीली इस तरीके से लिख सकते हैं 1/3 टाइम्स टोटल मास अपॉन वॉल्यूम इनटू VRMS वेलोसिटी का होल स्क्वायर, एंड यहाँ से फिर VRMS का एक रिलेशन भी निकल जाएगा. यहाँ पे आप इस mv को ρ/3 भी लिख सकते हो, तो एक बहुत स्टैंडर्ड रिलेशन आ जाएगी कि डेंसिटी ऑफ गैस से आपकी वेलोसिटी कैसे रिलेटेड है. सो यहाँ से from here you can finally decode this formula of RMS velocity of any gas, that will be 3 times P by rho. 3 टाइम्स p बाय रो। देखो यहाँ पे वी आर एम एस, p इधर जाएगा, 3 ऊपर जाएगा, सो 3 टाइम्स p बाय रो जो हो जाएगा ये आपकी RMS वेलोसिटी हो जाएगा। अब यहाँ पे एक क्वेश्चन ये भी आता है कि क्या प्रेशर बढ़ाने से RMS वेलोसिटी बढ़ जाएगी मॉलिक्यूल्स की? नहीं, प्रेशर बढ़ाओगे तो डेंसिटी भी इक्वली बढ़ेगी, तो RMS वेलोसिटी पे कोई फर्क नहीं पड़ेगा। दिस इज वेरी इंपॉर्टेंट। या अगर आप बोलो डेंसिटी बढ़ाओगे, तो डेंसिटी बढ़ाओगे तो किसी तरीके से बढ़ाओगे ना, यू विल जस्ट इंक्रीज द प्रेशर एंड उसकी डेंसिटी को इंक्रीज करोगे। सो डेंसिटी इंक्रीज करने के लिए आप प्रेशर एक्सर्ट करोगे चारों तरफ से, एंड उसके सिग्निफिकेंस में जितना प्रेशर इंक्रीमेंट होगा उतना ही आपका डेंसिटी भी इंक्रीमेंट होगा, सो ओवरऑल वेलोसिटी सेम रहेगी। सो वेलोसिटी, RMS वेलोसिटी ऑफ मॉलिक्यूल्स बढ़ा सकते हैं क्या? बिल्कुल बढ़ा सकते हैं। व्हाट यू कैन डू इज p बाय रो को, what you can do, p ko you can use that ideal gas equation, right? You can use this ideal gas equation, pv is equal to nRT, and यहाँ पे इस n को total mass upon molecular mass लिख सकते हो या molecular weight लिख सकते हो। this p ये जो v है, this v it can be written as p by rho, right? It can be written as, just give me a moment, I'll just write it down. So what I can do is I have this PV is equal to nRT, which can be written as m upon molecular weight into RT. Okay, this volume, how it can be written? It can be written as total mass upon its density is equal to mRT upon molecular weight, and this m gets cancelled, so P by rho is what? It's RT upon molecular weight, and this is what written over here. So velocity RT upon molecular weight से related है, and यहाँ से what we can decide is that ये जो RMS velocity, that is a direct figure or is in direct relation with temperature. See, R is constant, molecular weight is constant, so RMS velocity will be directly proportional to temperature. So as you increase the temperature, there you have it. There the individual RMS velocities or the RMS velocity of the entire gas will increase, thereby signifying कि individual velocities जो V1, V2, V3 हैं सारे molecules की वो भी increase होंगे. So only and only method to increase the velocities of gases is to increase the temperature. And how it is related? RMS velocity is related with under root of T, that is temperature. And just mind the statement because it is very extensively used. You get so many questions based on that जहाँ पे RMS velocity आपका temperature से related होती है. ठीक है सर, perfectly आपने सही बोला. अब एक और फिगर आता है हमारा आपने गैस की बता दी हमें RMS वेलोसिटी. अब गैस की हमें RMS वेलोसिटी, ठीक है, वी नो द RMS वेलोसिटी ऑफ गैस, बट आप इंडिविजुअल मॉलिक्यूल्स की कैन यू जस्ट टेल अस व्हाट इज द वैल्यू ऑफ RMS वेलोसिटी? So that also I can do. What I can do is I can replace this R by another constant which is more popularly known as Boltzmann constant. Boltzmann constant, ठीक है. And don't remember its figure. आपको maximum times ये figure आंसर शीट में दिया रहता है. जो भी क्वेश्चन पूछता है उसमें Boltzmann constant का फिगर आपको दिया रहता है. You don't have to specifically remember the value of Boltzmann constant. But the concept over here is जो R है वो K से related होता है. So R is equal to Na times K. And Na is what? Na is Avogadro number. So R is equal to Avogadro number into K and K is Boltzmann constant. So हम क्या करेंगे, इस R की जगह यहाँ पे Na into K लिख देंगे. So ये जो फिगर हो जाएगा, ये जो टर्म हो जाएगा RMS velocity, this will be equal to under root of 3 into K into Na into T divided by molecular weight. And what is molecular weight divided by the total number of molecules or the Avogadro number? It is the molecules, it is the weight of each of the molecules. This is what कि 6.023, देखो 1 मोल में ही molecular weight भी होगा और 1 मोल में ही Na number of molecules भी रहेंगे, right? 1 मोल में ही molecular weight भी होगा and 1 मोल में ही total number of molecules Avogadro number के बराबर होंगे. So molecular weight divided by Na will give you what? The mass of each molecule, right? So this mw divided by Na, this Na will come down and mw divided by Na will actually give you the value of mass of each molecule, and there you have this RMS velocity in terms of mass of each molecule, right? Where m is actually what? It is the mass of each molecule. So this way also you can express, if mass of each of the molecules is given to you, you can very well know the value of RMS velocity. ठीक है सर, perfect. Now let's move ahead and talk about the second important velocity, that is average velocity. So what is average velocity? We have studied about RMS velocity and yes, RMS velocity हमें पता चल गई, that is under root of 3RT upon m. Cool, perfect sir. Now आप ऐसी average velocity का भी significance दे दो. अब we know RMS velocity का उतना significance नहीं है pressure के terms में, मतलब pressure we cannot define in terms of average velocity, but still we want to know the figure. So the figure of RMS average velocity is under root of 8 RT upon pi times mw, that is molecular weight. So जो वहाँ पे 3 था यहाँ पे 8 by pi हो गया, ठीक है, and RT upon m को p by rho भी कर सकते, तो 8 by p by rho, ठीक है. इसी के साथ साथ there is one more kind of velocity that is known as most probable velocity. Now what is most probable velocity? So most probable velocity वो होती है कि suppose you have a gas and there might be substances, they are for the time being they are at rest. There might be substances जिनकी velocity बहुत ज़्यादा है, but होगा क्या, कुछ एकाध range होंगी velocities की where maximum chunk of all the molecules whose velocity will lie in that range. See, suppose if I am about to tell you the figure, so it is suggesting what the number of molecules and it is suggesting what the figures, the velocity figure. So the curve somewhat is like this, and this is suggesting what कि इस range की velocity, मतलब ये maximum velocity है, इस velocity में ज़्यादातर molecules आए हैं, ज़्यादातर molecules इस range की velocity में आए हैं, और यहाँ पे बड़े कम number of molecules आए हैं, या यहाँ पे जैसे जैसे आप बढ़ाते जाओगे, इसके आगे का कर्व नहीं है, ठीक है, इसके आगे का कर्व नहीं है. So see, I'll just explain it in a simple manner. It just says that कि which is the velocity which has the most probability to occur. मतलब कौन सी ऐसी velocity है, क्या है, it is 5 meter per second. Say suppose I have 10 number of molecules and amongst them one has 0 velocity, one has 2 velocity. Around 5 of them is having velocities in the range of 10 meter per second, and the rest 2 or 3 are having velocities in 2 or 3. So what is the most probable velocity? सबसे ज़्यादा probability किस velocity की आने की? That 10 meter per second, right? So that 10 meter per second जिसके corresponding ज़्यादा number of molecules होंगे, that is what the most probable velocity is, or the most probable speed is, and उसकी जो value होती है that is equal to 2 RT upon molecular weight. Okay, so this mm over here is what? It is molecular weight. It can be expressed in terms of Boltzmann constant as well. Okay, and वो RT upon molecular weight को आप P by rho से भी convert कर सकते हो, ठीक है. So यहाँ से ये चीज़ समझ में आती है कि we now have RMS velocity as well. What is the relation of RMS velocity? RMS velocity is under root of 3 RT upon molecular weight. Then we have average velocity as well. उसका क्या relation है? Under root of 8 by pi RT upon molecular weight. And we have now this most probable velocity as well, जिसका relation होता है under root of 2 RT upon molecular weight. So now what we can derive from this is RT upon m तो सब में same है. So the figure, the coefficient of RT upon m is, so it is maximum for 3, it is then in the medium range for 8 by pi, and the least for 2. So there we can actually deduce that RMS velocity is obviously the maximum, then there is average velocity, and then there is mean velocity, and so goes here relation, and so goes their ratio as well, how their ratio is. So sometimes if you are getting mean most probable, then you can very well find the value of average as well as RMS velocity. So do keep this figure in mind, it is very, very important. Okay, now let's move ahead and talk about this translational kinetic energy, what this function is. So now what we can actually find, or we have seen 3 types of velocity, and now what we can deduce is the most justifying kind of velocity is obviously RMS velocity, right? Because using the RMS velocity we can actually very clearly find out the value of pressure, which is instead very near to the exact pressure which that gas is exerting. So we took that and we actually understood that कि हमें calculations में और जहाँ wherever we'll be using the case of velocity of a gas, we'll be considering the RMS velocity as well. ठीक है. So now let's suppose that individually all the molecules are having the velocity equivalent to RMS velocity. So there will be a summation of all those kinetic energies with all those molecules, and the reason is that individually molecules are having those velocities, and because of those velocities they already have a mass, right? So that mass half mv square is actually equivalent to their individual kinetic energies. And what is the summation of all those energies? So what is the summation of all those energies is given in front of you. So the summation, so what you are seeing over here 3 by 2 kT. So now let's add all of them. So what you are getting over here 3 by 2 kT is actually the kinetic energy of a molecule, of a monoatomic molecule. ठीक है. And the expression of this is, so this figure which you are seeing is, it is kinetic energy of a molecule. ठीक है, this is of a molecule and specially of a monoatomic molecule. Why monoatomic? Because of this three figure. Because of this three figure, it has a degree of freedom equivalent to 3. And if I talk about kinetic energy of a gas, then this K, this Boltzmann constant which you are viewing over here, this turns out to be 3/2 times RT. Okay, and this is what? This is the kinetic energy of that entire gas. Okay, this is the kinetic energy of that entire gas. What I have done is just multiplied that Na number with it. Na से multiply कर दूंगा इसको, तो K times Na will give you the value of R, and this will actually be equal to kinetic energy of the entire gas, and this is actually equal to kinetic energy of a molecule. So the summation of all these kinetic energy, the summation of all these kinetic energy is what equivalent to your internal energy of the gas, and this is what the final interpretation of kinetic theory of gas is. ठीक है. So according to kinetic theory of gas says the internal energy of an ideal gas, ये पूरी जो कहानी थी, everything, whatever this energy quotient, that individual molecules have energy, so this was all to just find one particular thing that हमें सबका सम करके फाइनली वो इंटरनल एनर्जी का फिगर डिटेक्ट करना है कि what is actually internal energy. ठीक है. So according to KTG, the internal energy of an ideal gas is the sum of the total translational kinetic energy of its molecules. So when we add all those translational kinetic energies of all those molecules, what we'll be getting is, we'll be getting the value of the internal energy of that gas, and that can very well be represented by this expression, that is n into f/2 into k delta t, where f is actually the degree of freedom. The degree of freedom. Okay, so इस तरीके से आप बहुत अच्छी ढंग से बता सकते हो. यहाँ पे देखो, अगर मैं गैसेस की बात करूं तो इतनी एनर्जी हो जाएगी, इस n को मैं कैपिटल N अपॉन एवोगैड्रो नंबर ले सकता हूँ, वो एवोगैड्रो नंबर r के नीचे चला जाएगा तो फिगर k हो जाएगा. तो आप बोल्ट्जमैन कांस्टेंट के टर्म्स में भी याद कर सकते हो, या फिर आप रियल गैस कांस्टेंट के टर्म्स में, सॉरी नॉट रियल गैस, यूनिवर्सल गैस कांस्टेंट के टर्म में भी याद कर सकते हो. बट जो चेंज इन एनर्जी है, जो चेंज इन इंटरनल एनर्जी होगा, वो जरूर याद रखना, दैट विल बी इक्वल टू डेल्टा यू इनटू f/2 टाइम्स nr डेल्टा टी. ठीक है. एंड ये जो फिगर आप देख रहे हो, इसको आप इस तरीके से याद रखोगे कि डेल्टा यू विल बी इक्वल टू NCV डेल्टा टी, क्योंकि यही फिगर आपका बाद में भी यूज होगा. ठीक है. बाद में कैसे यूज होगा, ये जो आप CV देख रहे हो, दैट इज द हीट कैपेसिटी एट कांस्टेंट वॉल्यूम, दिस विल बी इक्विवेलेंट टू f/2 टाइम्स r. और यही चीज आपको याद रखनी है. जो CV आप देख रहे हो ना, दिस CV इज व्हाट, इट इज f/2 टाइम्स r, और जहां पे डिग्री ऑफ फ्रीडम होती है f. और इन सब के बारे में आई विल बी वेरी नाइसली, वेरी क्लियरली टॉकिंग विथ यू, क्या होती है डिग्री ऑफ फ्रीडम और कैसे हम स्पेसिफिक हीट कैपेसिटी एट कांस्टेंट वॉल्यूम, या फिर आगे चल के CP जो कि हो जाएगा हीट कैपेसिटी एट कांस्टेंट प्रेशर, कैसे डिवाइस करते हैं. सो एंटायर गेम, दिस एंटायर गेम ऑफ KTG इज ऑल अबाउट डिटेक्टिंग दिस internal energy. Now let's look at some more important terms. What is degree of freedom and what is this एनर्जी का डिवीजन कैसे होता है, इक्वली इक्विपार्टीशन ऑफ एनर्जी, इन सब के बारे में भी थोड़ी थोड़ी बात करते हैं. सो डिग्री ऑफ फ्रीडम इज एक्चुअली डिफाइंड एज, से सपोज I have energy. So in how many ways I can store my energy? In how many ways? So maybe I have my energy in my hands. That's the reason my hands are moving. So both of my hand means two ways, both of my leg means two ways, and something like that. So it's not the proper sense of conveying it to you. But what I just mean by saying this is that suppose you have a molecule. So molecule can have, say suppose I'm talking about a monatomic molecule. Okay. So let's be talking about a monatomic molecule. So monatomic molecule can have oscillation or movement in how many axes? So it can have a movement along x-axis, it can have a movement along y-axis, even it can have a movement along this z-axis, which will be perpendicular to both these axes. So if the motion can be along 3 axes, then the energy, the kinetic energy can be stored among 3 directions or 3 ways, and this is what actually degree of freedom is. Okay, and going by the definition on books, so it actually says the total number of coordinates or independent quantities required to describe the position and configuration of the system. So this is what degree of freedom is. But in a normal sense, समझने के लिए what we can see is energy कितने तरीकों में store हो सकती है, कितने मोशन में, कितने रास्तों में store हो सकती है, and this is what actually degree of freedom is. And let's talk about the degree of freedom. So if I talk about a monatomic molecule, so what is a monatomic molecule? Take example of a helium and argon. So if I take an example of helium and argon, then the degree of freedom of that monatomic molecule will be equal to 3. Now if I talk about a diatomic gas, say suppose H2O2N2, if I talk about a diatomic gas, so there are 2 atoms over here, right? So इनमें energy कितने तरीकों में हो सकती है? So 3 तो इनके translational हो गए and 2 rotational होंगे. And how come is rotational? So suppose we have 2 hydrogen molecules, so they can rotate, like they इनका axis of rotation हो सकता है और एक axis of rotation ये हो सकता है. Say suppose this is a pen, so it can rotate like this, it can even rotate like this, and it cannot rotate like this. This motion is not at all visible to you. So 2 axis इनके about rotation, rotatory motion की तरीके में भी energy store हो सकती है, and hence the reason their degree of freedom is equivalent to 5. So do remember this figure. Diatomic molecule, whenever they are giving, they will not specify you the figure of degree of freedom. You have to understand कि if they are talking about diatomic gases, then the degree of freedom is equal to 5, and if they are talking about monatomic gases, then the degree of freedom is equal to 3. They can specifically give you a gas. Say suppose I am working on N2 gas. So this should be very clear in front of you that what degree of freedom you need to take and what will be the values of heat capacities at constant volume and constant pressure over there. What will be the value of gamma, the ratio of both the heat capacities. So you need to know all these things. Now let's say suppose if I talk about any polyatomic material or polyatomic gas. So polyatomic gas is actually apart from these monatomic and diatomic. So polyatomic can be CO2, NH3, any gas which you wish for. And for them, then you will have to look into the conditions. So now say suppose if you have a linear molecule like CO2, so CO2 is a linear molecule, but H2 on the other case is not linear, so and NH3 is also not linear. So if you have a non-linear molecule like NH3, then degree of freedom will be 6, and if you have a linear molecule, then degree of freedom will be 5. So then you will have to be very specific, and those chemistry students will be very benefited from this topic because they specifically should know which of the molecules are linear, which aren't, and based on them the degree of freedom will be justified. Then if I talk about at higher temperature, so if linear is also there, but at higher temperatures they possess one different degree of freedom as well, and it increases by 2, a value of 2. So 3 translational, 2 rotational, and then there occurs vibratory motion as well. In vibratory what will occur? It will be a to and fro motion. Okay, it will be a to and fro motion, one along this and one along this. Okay, so then there can be 2 more to it. So what I've just mean to say is mostly what you will encounter is these about monatomic and diatomic, and you need to remember their degree of freedom only. Mostly I have seen so many questions, and rarely it becomes a chance that you're given about any polyatomic gas, and if it is given, then they will be specifically telling you about degree of freedom, or one way or the other they will be specifying you about the heat capacities. So by that method you can actually get to know what is the value of degree of freedom. So there will be some way or the other. There is rarely a chance they ask about polyatomic gases, the degree of freedom, but mostly the question is always revolving around diatomic and monatomic. So do remember these 2 figures in your mind. Okay, now let's talk about this very famous law of equipartition of energy. So what it says is, say suppose a gas is having some energy. A gas is obviously having some energy. A monatomic gas is having an energy 3/2 RT for a single mole. Okay, and this is obviously its internal energy, right? So what this law of equipartition of energy says is, so whatever is the degree of freedom, so let's say suppose for a monatomic molecule, I clearly told you along the 3 axes the molecules can move. They can move along x axis, they can move along y axis, and they can even move along z axis, right? So whatever energy that molecule is having or that gas is having, that entire energy will be equally distributed among all its parameters or among all its degree of freedom, and this is what law of equipartition energy is all about. So according to law of equipartition of energy, the total kinetic energy of a thermodynamic system consisting of a particle is equally distributed among all its degree of freedom, and this is what that statement is. This grand rule is all about. So for n moles of a gas with f degree of freedom, its total kinetic energy will obviously be equal to half n FRT, obviously. So for a monatomic it will be 3/2 nRT, and for monatomic it will be 3/2, and for diatomic it will be 5/2. So what this means is along all the 3 axes x, y and z, 1/2 nRT, 1/2 nRT and 1/2 nRT will be distributed, and over here for diatomic it will be 1/2 1/2 along all the 5 axes, that is along the XYZ and one along the rotational motions. Okay. So based on that, I now suppose you have understood the entire case of this equipartition of energy. Now molar specific heat of gases. So basically you will be encountering two molar specific heat of gases. One will be at constant volume and one will be at constant pressure, Cp and Cv. So you need to memorize all those things about it and very well know what they actually are. So if I talk about this constant volume molar heat capacity, it is equal to delta Q upon N delta T, and delta Q in this case at constant volume, this will be very recently discussing that how delta Q is only equivalent to delta U over here. On the other hand, if I talk about this delta QP, it will be equal to delta U plus delta W. Okay, so how this is occurring, we'll be very nicely talking, but for the timing just remember whatever is the energy supplied or energy extracted divided by N times delta T will give you the value of heat capacities, and this formula we have very well discussed in thermal properties of matter. So those who haven't seen that crash course, kindly do visit it and understand it. And obviously I told you at the start of the lecture only कि कैसे आप वो coupon codes use करके वो questions भी कर सकते हो. So do watch. My personal suggestion is to do watch those sessions before attempting the test, because you will be knowing and getting a glimpse of the entire syllabus, entire content of that chapter, and that will be very useful when you will be trying on those questions. Okay? And if you are actually loving this session or these sessions, if you are getting any takeaway elements from them, do refer it to your friends, like this session, and also subscribe to this channel with hitting that bell icon as well to get regular updates. Okay? So this was the discussion about heat capacities, and there's a relation individually between them. So Cp minus Cv is equal to R. This is actually a very important relation as well, and there's a Mayer's formula actually which actually relates this formula. So Cp minus Cv is equal to R. Okay, for an ideal gas, Cp minus Cv is equal to R, and Cv is actually equal to F by 2R. So Cp can be very well decoded just by adding it with one more R, so it will come out to be F plus 2 by F into R, right? Is it correct? No, it is not correct, sir. Why? Because it will be F by 2 plus 1, so F plus 2 by 2. Okay, F plus 2 by 2, and this is the value of Cp. So Cp and Cv, and what will be the value of Cp upon Cv? So Cp upon Cv is equivalent to gamma. So gamma will now be equal to F plus 2 by F, and this will be equal to 1 plus 2 by F. So you can very well find the value of gamma, Cp and Cv only if you have the knowledge of degree of freedom, which you very well know. For monatomic it will be equivalent to 3, for diatomic it will be equivalent to 5, and these are the two figures which you readily need to remember, because maximum questions will be asked from that thing only. Now if I talk about segmenting them, so suppose it's monatomic, diatomic and polyatomic with degree of freedom as 6. So these will be the individual Cv's value, this will be the individual Cp values, and gamma you can very well relate what it is. Okay, so this is very important. Sometimes what happens is gamma's figure is given to you, it is 1.4. So don't go in the calculation part, you can very well know, okay, 1.4 actually, then the molecule will be a diatomic one. And if the gamma is turning out to be 1.33, then the molecule will obviously be a polyatomic one, and if 1.66, then monatomic one. But you don't need to remember them. Okay, this is just for your conceptual awareness ki what actually these figures are and how we calculated them. Okay? So just have a look towards them and how they were calculated. You should be remembering that only. Now let's discuss about this another important thing, that is mean free path. So what is actually mean free path? So mean free path actually means is that say suppose if I talk about your mean free path. So your mean free path at your house will be that today you were scolded by your parents, and the next time when you are scolded by your parents, that is your free path, right? So the time interval between your two scoldings is actually your mean free path, and similarly over here as well. So the average distance each molecule has to travel before it gets collided with another molecule. Okay, so that is actually the mean free path. Suppose this molecule was in motion, it just collided with this molecule over here, and it had its velocity change over here, and again it is colliding over here. So this entire path, so it will be an average of all those paths, and this will give you the figure of the mean free path. So mean free path is the average distance covered by a molecule between two successive collisions. So you just need to remember the figure of it, and this mean free path is equal to 1 upon root 2 pi d square into n, where d is obviously the diameter of the molecule and n is the number density, total number of molecules in the gas divided by its total volume. ठीक है, so this will be actually equal to your mean free path. And do remember this figure, because a direct question I have seen asked in JEE Main in 19, it was directly about how lambda is varying with n. Okay, so they were given two gas samples with two different number densities. The diameter of the molecules were same, but only the densities were changed, and they were asking about the mean free path, the ratio of them. So do remember it. It is also very important, because you can encounter one or the other question based on this topic. Okay, now let's solve this question to better understand what we have just learned. So the minimum heat energy required, and equally what you can do is आप इसका आंसर मुझे चैट लिस्ट में बता सकते हैं. Let's see कौन जीतता है, आप या मैं. So यहाँ पे क्या हो रहा है, the minimum heat energy required to cause complete dissociation of n moles of H2 gas. n moles हैं H2 gas के at constant temperature. So what we need to find, हमें वो minimum heat energy पता करनी है जो कि required होगी H2 gas के n moles को तोड़ने के लिए. We need to dissociate them. Okay, ठीक है. So एक बात बताओ, अगर NH2 moles break down होते हैं, it's a normal chemical reaction, right? अगर आप chemistry के lectures देख रहे होंगे, so you will be very well with them. So यहाँ पे कितने individual hydrogen के atoms आएंगे? Sir, 2 times n into hydrogen atom. And ये है आपका diatomic molecule, and ये है आपका monatomic molecule, right? अब monatomic molecules में ज़्यादा amount of internal energy होगी कि diatomic में होगी, और जितनी ज़्यादा होगी उस हिसाब से we'll get to know कि whether we will have to provide some energy or we will have to extract the energy. So what we can do is we can individually calculate their internal energies, right? So the internal energy over here, Ui, can be written as, so what is the degree of freedom? We very well know it is represented as F by 2 times nRT, right? And over here also we can use that formula. It will be F by 2 into nRT, and it is obviously occurring at a constant temperature. Universal gas constant is same. The number of moles are changing. The number of moles are obviously changing. So the degree of freedom over here, it's a diatomic gas. So degree of freedom will be 5 by 2 into the number of moles was 1. So it will be 1 into R into T. And over here it will be 3 by 2, obviously, because it's now monatomic, right? And the number of moles are 2n. It is 2n. So it will turn out to be 2n, and over here also it will turn out to be n. So it will be R into T. So can you see? It is 6n RT by 2 and it is 5n RT by 2. So obviously there is a difference. More kinetic energy is towards the latter one. So obviously 6 by 2 nRT minus 5 by 2 nRT will give you nRT by 2, and this is the correct answer. So I suppose you all understood this concept, how we just got to this result. Okay, now before proceeding further, let's take a quick break, and after that what we'll be doing, we'll be just starting off with this topic of thermodynamics, that is Zeroth law. We'll be covering all the concepts of thermodynamics in a very quick span of time. So I'll be just returning in a moment. By that time, just revise and create mind maps in your mind, whatever things are there of thermodynamics. I'll be back in a moment. Okay, bye bye. Okay, hi everybody. So I suppose you have got the answer, but there's no question. So हम तो thermodynamics start करने वाले थे, and इससे पहले हमने एक question complete किया था, and हमने KTG पूरा complete कर दिया है, ठीक है? So हम start करने वाले हैं what? We are going to start this session of Zeroth law of thermodynamics. यहाँ से देखो, thermodynamics kick start हो जाएगा, and thermodynamics is all about in physics. If I talk you about thermodynamics, then thermodynamics is all about first law, second law, and this obviously Zeroth law, which is obviously very simple. So how many of you are here? Raktim, Sachin, Devendra, just tell me यार अपने friends जितने भी हैं ना आप लोग के, just suggest them these lectures, they are very beneficial for them, ठीक है? बहुत ही जल्द आपकी डेट रिलीज हो जाएंगी, एंड फिर आपको then when the date is there तब आप तैयारी करना स्टार्ट करोगे, तो then the time will be much more. So you very well know you can use this code. आप ये sessions देख सकते हो, do give them. बहुत ही जल्द what we'll be doing, we'll be releasing the test series as well. वो test series complete होंगी जिसमें physics, chemistry, maths एकदम they will be just a replica of what JEE Main is all about. JEE Main के जैसे papers आते हैं वैसे ही वो test series रहेंगी, और that you can also avail, वो भी आप दे सकते हो. But उससे पहले what you need to do, you need to go through with the entire syllabus. So we have created a particular timeline जिसके according पूरा का पूरा entire chapter सारे 11th plus 12th सारी ही चीज़ें cover हो जाएंगी. If I talk about this chapter thermodynamics तो बहुत ही ज़्यादा eminent हो जाता है, even in physics, even in chemistry. बस एक माइनर सा डिफरेंस होता है जो कि मैं अभी डिस्कस करूंगा जैसे ही हम फर्स्ट लॉ ऑफ थर्मोडायनेमिक्स के बारे में बात करेंगे, ठीक है? सो ज़ेरोथ लॉ के बारे में बात कर लेते हैं. ज़ेरोथ लॉ क्या है? इफ अ बॉडी ए सेपरेटली इन थर्मल इक्विलिब्रियम विद बी एंड सी, देन बी एंड सी आर आल्सो इन thermal equilibrium with each other. So what it says is actually कि A जो है it is in thermal equilibrium with both B and C. Okay, that means if there is a diathermic wall, that means no heat exchange is happening between them. Adiabatic wall means there cannot be no heat exchange because the wall, जैसे कि एक thermos होता है, thermos never allows heat exchange between it, the inside material and the surrounding. So the same case is with adiabatic wall, heat exchange allow नहीं करते. They don't allow the heat to escape from one point to another. एक end से दूसरे end तक जाने नहीं देते. But diathermic wall allows that, but there is no heat exchange occurring between A and B since they both are in thermal equilibrium with A. If a body is in thermal equilibrium with another body, that means the temperature are same, no heat is flowing, right? So then what we can conclude is that B and C will obviously be in thermal equilibrium with each other. Very simple law, it's a very simple law, and all of you must be knowing that. Now let's talk about work done by gases. So work done, do you know the formula? It is obviously F into delta R, right? F delta R होता है work done का formula. So what you need to do, just multiply A and A both in the denominator and numerator. So A into delta R or A into delta X will actually be equal to volume, and F by A is what? It is pressure. So work done ka in gases what we will be using, the formula is P delta V, and if we are about to infuse calculus into it, then the formula will be integration P dV from V1 to V2. Obviously definite integration करोगे, so integration of P dV will actually give you the value of work done by gases in expanding the gas by a very small volume dV if the pressure is P. Okay, so इस तरीके से work done by a gas calculate किया जा सकता है, and we'll be using it because obviously we'll be doing the thermodynamic study on gases only. It's all about the heat exchanges and all, ठीक है? Let's move ahead and talk about this work done. So graphically अगर आपको मान लो, if you are given with a graph of P and V, so suppose this graph of P and V actually suggests that the gas was at initial temperature, initial pressure and volume as P1 and V1, and finally at point B it reaches at a pressure and volume as P2 and V2, and it is actually following this path. Then what will be the value of work done? So PdV very clearly specifies you the small amount of work done, and that can be calculated. Suppose this is the value of dV, so into P will actually give you the area of this small shaded rectangular region, right? And if you just integrate it from V1 to V2, then what you will get? You will get the entire area, that is area of the curve, and this area of the curve will actually specify the entire integration of that those dWs, and that is actually what? It is actually the entire work done. Work done by the gas is what this integration of dW is, and this will give you, how can you find it using a graph? Just calculate area under the curve and you will readily get this value of work done by the gas. Okay, now let's bring into first law of thermodynamics and also talk about how physics wala thermodynamics is different from chemistry wala thermodynamics. Okay? So what thermodynamics first law states in physics is that, let's say suppose you are doing or giving energy to a system. Let's say suppose we have a gas over here who has its molecules and we are providing some amount of energy, or this gas has been kept just above a burner, a gas burner. So energy will be supplied to this gas, and on the supply of this energy, what will happen? Some amount of this energy will actually get used up in imparting or giving velocities to those molecules. So what will happen? जैसे जैसे आप energy देते जाओगे, molecules ज़्यादा तेजी से move करने लगेंगे. So initially they were moving very easily. Now they'll have another type of motion जिसमें बहुत तेजी से move होंगे. तो उससे होगा क्या? What we can finally deduce from that is, interpretation ये होगा कि उसका energy का कुछ portion internal energy बढ़ाने में गया. That means some amount of the energy given to the gas got used up in increasing the internal energy of the gas, because their individual velocities, the molecules' individual velocities will increase, thereby increasing their individual kinetic energies. And individual kinetic energies increase होने से क्या होगा? उसकी internal energy increase हो जाएगी. And also what can occur? Some amount of molecules will hit this upper surface, and this upper surface will also move upward. Right? This upper surface will also move upward, and instead there is a work done over here, right? Because this obviously this cap over here, this piston over here will have some mass, and if it is moving upward, then there will be some work done. So all in all, I just want to sum it up by this statement that if you impart or if you give some delta Q amount of energy to a system, some amount of it will be used up in increasing its internal energy, and some amount of it will be used up in doing work done by the system. Okay, work done by the system. And this work done by the system in physics is considered to be positive, and in chemistry this work done by the system is considered to be negative. So there the statement just turns out over here, this delta W is shifted over here, and there the statement says is that internal energy of any gas can do two things. What it can do? It can actually do work done by the system, and it can provide energy to the surroundings as well. So the chemical reactions happening inside any gas, that will be the change in its internal energy. There will be a change in its internal energy, and based on this change, what it can do, they can do some work out on the they can do some work by the gas, and they can also provide some energy to the surroundings, like an exothermic reaction. Okay, or if in case its energy is not decreasing, internal energy is not decreasing, it is increasing, then it becomes an endothermic reaction, wherein some work has to be done and some energy has to be provided, then only the change in internal energy will occur. So this is all about chemical reactions, but in physics we talk about all those mechanical things, right? So in mechanics or the thermodynamics in physics actually tells us that if you provide delta Q energy, it will be used up in two things. One will be increase its internal energy, and the other will be increase or do a work done on the top piston. So work done by the system plus increase in its internal energy will be the two components of the amount of energy provided by you to the system. Okay, and work done by the system is obviously denoted in physics, as I have clearly told you, it will be PdV with limits V1 to V2. Okay, take it. Q and W are both path functions, that is, they will depend upon the path whatever you are following. On the other hand, U is a state function, and it will depend upon your initial and final state as well. If your initial and final state are same, so what will be the value of internal energy? Just tell me in the chat list कि अगर एक object की initial और final position same होती है, then what will be the value of the change in its internal energy? It will obviously be equal to 0, क्योंकि internal energy is a state function यार. If you having initial and final position both as same, then obviously your temperature will be same, and if your temperature is same, then what you can deduce is, you can obviously say that NCV delta T में delta T 0 हो जाएगा. That means delta U will amount to 0. Okay, ठीक है. So for a given gaseous system, delta U is obviously defined as NCV delta T, and this thing you should remember. ठीक है. Now let's talk about 4 very important processes and dial in that first law of thermodynamics in them. The first process is isochoric process, and isochoric process is all about when volume is constant. So if volume is constant, that means if I have an ideal gas, then PV is equal to nRT, right? So P by T then will be constant, and also what I can deduce from this is that P will be directly proportional to T. So P and T will have a linear relation between them, right? Y is equal to mx. So this will be the graph for P and T, and this will be the curve for P and V. So V is obviously constant, so the graph will be a vertical one wherein volume is not changing. So obviously since dV is equivalent to 0, dV is equivalent to 0, that means work done in isochoric processes will be equal to 0, and this is a very golden line. That work done, if somebody is asking you about the work done in isochoric process, strictly tell them that the answer will be 0. Why you are asking me? Because obviously there is no change in volume, and if there isn't any change in volume, that means that PdV will have that dV equal to 0, and work done will obviously equal to 0. So then what will the first law of thermodynamics act over here? So in first law of thermodynamics, delta Q is obviously equal to delta U plus delta W, right? And if this portion is coming out to be 0, then delta Q entirely will be equivalent to delta U only. So delta Q will be equal to delta U, that is NCV delta T. So delta Q will turn out to be only equivalent to NCV delta times T. Okay, and this is the expression for the amount of energy change. Whatever amount of energy you are giving, it will entirely be going in increment of the energy, of its internal energy. Now if I talk about the isobaric process, so in isobaric process what occurs is P becomes constant. P becomes constant, so using an idealized equation we can actually say that V upon T will be constant, or what we can finally deduce is that volume will be directly proportional to its temperature. So as temperature will increase, volume increase, volume down, temperature down. So if I talk about a PV curve, then there will be a horizontal line because pressure is not changing, but if I talk about a VT curve, then there will be a line representing Y is equal to mx. Okay, and if I talk about a PT curve, obviously pressure is constant, so again a horizontal line. Okay. Now if I talk about the work done, we need to specify work done in all the four processes. So work done in isochoric was equivalent to 0, but work done in isobaric won't be equal to 0. Instead what it will be, so work done relation you very well know, work done is integration PdV. Now if this pressure is constant, then it can very well come out of the integration sign, and integration of dV will be what? From V1 to V2 it will be equivalent to P times delta V, where delta V is representing V2 minus V1, and this is what is written over here. So P delta V will represent what? Work done by the gas. Now P delta V can also be very well calculated if we have this equation. So suppose I have PV is equal to nRT, and I just place delta on both the ends. So delta PV will be equal to delta nRT, right? And delta PV, so P is constant, P will come out and it will remain as P times delta V. It will be equivalent to nR delta T, right? So P delta V can be replaced by nR delta T, and this is what is written over here. Okay, so work done, remember it very nicely, that work done in isobaric processes is equal to nR delta T or P times delta V. Okay, let's move ahead and talk about isothermal processes. So as in the case of isochoric where volume was constant, as in the case of isobaric where pressure was constant, in isothermal processes temperature will be constant, right? Temperature will be constant, and since temperature is constant, so what I can finally deduce is that internal energy will be constant, because internal energy was what? Internal energy was NCV delta T. This was the value of internal energy. Now since temperature is constant, this becomes 0, and obviously delta U will be equal to 0. So there won't occur a change in the internal energy, and previously also I told you that the RMS velocity of any gas was actually depending upon pressure or rho? No, only on temperature, right? Because if we are increasing the pressure, then density also increased. But if you are increasing the temperature, then only velocity, that RMS velocity was increasing. So there isn't occurring any change in the temperature. So that means what? The individual velocities, RMS velocities, will remain same. And if the velocities are remaining same, then what we can finally deduce is there won't occur a change in the internal energy of a gas. That means delta U will be equal to 0. So mind it that in a isothermal process, delta Q, whatever amount of energy you are giving, will strictly go into the work done by the system. Okay, or work is being done on the system, that entire energy will be converted only into the energy provided by the system to the surroundings. Okay, so work done in isothermal process is equal to delta Q only, the amount of energy provided to it, where W okay, so in an isothermal process you can very well define the value of work done. How it will be? You can use this integration P dV and replace this V by nRT upon V, and this nRT will go outside, so it will be dV by V, integration from V I say Vf. So this is the relation which you will get. It is obviously in log of with base 10, so you will have to multiply. The answer will come in log, natural log of this Vf upon Vi with base E. So you can convert that base E into base 10 by just multiplying 2.303. Okay, so whenever you need to change log of any quantity with base E to log of that quantity with base 10, what you need to do, you just need to multiply this log with base 10 by 2.303, and you can very well change that base from E to 10. Okay, and obviously Vf upon Vi can also be replaced by Pi upon Pf, since what I can say is that since temperature is constant, that means Pv is constant, that is Pi Vi will be equal to Pf Vf. So Vf upon Vi will be equal to Pi upon Pf, right? Very clear, and do remember this expression of work done. It is very important. Remember all the expressions of work done in all the processes. They are quite widely used in the questions. Now if I talk about the curves, so Vt curve will be a vertical line, Pt curve will also be a vertical line, but if I talk about a Pv curve, so this will represent what? A rectangular hyperbola, right? A rectangular hyperbola, how it looks like? So a rectangular hyperbola has an equation xy is equal to k, that is a constant. So over here also Pv is equal to constant. So this curve is representing a rectangular hyperbola, and if I talk about the slope of a Pv curve, it can very well be defined by dp upon v, and that is equivalent to minus p by v. Okay, you do what? Do this thing that Pv is equal to constant, right? So just integrate it up with respect to v. So this will turn out to be dp upon dv times v plus p becomes constant, and this will become equal to 1. It will be equal to 0. So over here you can very well find that dp upon dv is coming out to be minus p by v. Okay, so using this relation you can very well determine what will be the slope of a PV curve at any of the points. That will be the ratio of p by v. Now let's talk about the very important fourth process, that is adiabatic process. Now what is the feature of adiabatic process is, as I told you, that adiabatic wall. So in adiabatic process there occurs no exchange of heat between the system and the surrounding. So it's just like a thermos, right? Hot water or hot milk placed inside a thermos. So there occurs no significant change in energy from surrounding to inside the system, right? So such kind of a process is only what? Adiabatic processes, wherein the delta Q quotient is 0. So there occurs no exchange of heat between system and surrounding. So what I can finally deduce is that delta Q, since it was equal to delta U plus delta W, and if this is turning out to be 0 according to first law of thermodynamics, and delta Q is 0 because it's an adiabatic process, then delta U plus delta W will equal to 0. So what I can finally deduce is that delta U will be equal to minus of delta W. That means if work has to be done by the system, then its internal energy will decrease, and if work is being done on the system, then its internal energy will increase. Okay, and this is what this expression is. Okay, now for an adiabatic process of an ideal gas, if we have an ideal gas, then this relation will come into action. PV ki power gamma will be equal to constant, and based on this relation we can very well calculate the work done in an adiabatic process as well, and that will be equal to 1 upon 1 minus gamma delta PV, or nr upon 1 minus gamma T2 minus T1. Okay, so this relation, since it is T1 minus T2, it should be T2 minus T1, then it will be 1 minus gamma. Okay, so this relation, what I have written over here is, it can be very well derived just using that it is integration P dV, and just replace this P by K upon V to the power gamma. Okay, and when you will just integrate it up, you will get this relation that work done is coming out to be 1 upon gamma 1 upon 1 minus gamma. Work done will arrive as 1 upon 1 minus gamma PF VF minus PI VA. Okay, so this will be the relation. Okay, and if you just change this PF VF minus PI VI by PV is equal to nRT, right? It is an ideal gas. So I can replace this expression, nR I can bring it outward. So nR upon 1 minus gamma will be equal to TF minus TI. Okay, and this is what this expression is. So T1 over here is initial temperature and T2 is final temperature. So I have just interchanged it, and this minus sign will be replaced over here. So gamma minus 1. So you can just remember this thing. So the better way of remembering it, the work done is, it will be delta PV upon 1 minus gamma, or NR delta T upon 1 minus gamma. Okay, so this is the better approach. Remember it in this fashion. Okay, remember it in this fashion, that what is the work done over here, and the work done in the case of isothermal was nRT natural log Vf upon Vi. If you just remember, this was the expression, and if you want it in log with base 10, then obviously you will have to multiply 2.303 as well. So do remember the work done in isothermal and adiabatic processes, because they are used quite extensively. Trust me on that. They are used so commonly that if you are not remembering it and deriving it at every moment, it will be a big trouble for you. Okay, Johnny, hi, how are you? So now if I talk about the slope of an adiabatic process, so the slope calculated, how we calculated the slope of PV curve in isothermal, the approach will remain same. So again the slope will be, it will be dP upon dV, and what I can do is I can actually use this expression PV to the power gamma is equal to constant, right? So I can just replace this P by K upon V to the power gamma and just integrate it up. So what I'll be finally getting is, the relation will turn out to be minus of gamma times P by V. Okay, and this will be the slope of what? It will be the slope of PV curve in an adiabatic process. So this is the expression for slope. Now let's do one thing. Let's first just study about polytropic process, and we'll draw the PV curves for all the processes. We'll be drawing it for isothermal, isobaric, then adiabatic, then this polytropic as well, and then you can get a clear picture about the PV curves. So if questions are arriving from PV curves, that what is the slope, which slope will actually represent what, which of the curves is actually representing which process, then you can very well segment them and understand how they are getting differentiated. So in a polytropic process, I can just say that PV to the power alpha is equal to constant, where alpha is any constant value, right? So as in the case of adiabatic process, PV to the power gamma was constant, where gamma was obviously the ratio of CP's to CV. Here alpha can be any value depending, because it's a polytropic process, right? So in such a case, what will be the expression for work done and all those things? So work done over here can be very well represented by the same expression as in the case of gamma. It will be delta PV upon 1 minus alpha, and that can be replaced by NR delta T upon 1 minus alpha. And specific heat of the gas, how that can be calculated? So that will very well be equivalent to, say suppose you have this delta Q is equal to delta U plus delta W, right? So what is the value of delta U? And delta Q when you replace by NC delta T, where C is the specific or the molar heat capacity of this polytropic process, any process. Delta U is always NCV delta T, and work done we have just now calculated, it is equal to NR delta T upon 1 minus alpha. Just remove this N delta T, N delta T, N delta T, and what you will be getting is that C will turn out to be CV plus R upon 1 minus alpha. Okay, so this is the specific heat capacity of this gas. Okay, now let's move ahead and talk about cyclic processes as well. So what are cyclic processes? Cyclic processes are those where the states again repeat. So the initial and final state are same, and if since the initial and final state are same, my mind will actually work and tell me, okay, so then internal energy will be amounting to 0. And the reason is that internal energy is a state function. It will depend upon initial and final state. So if they aren't different, they are same, that means the temperature was same initially and the temperature will remain same finally as well. That means delta T will be equal to 0. That means delta U will be equal to 0. So if delta U is equal to 0, then what I can actually term is that delta Q will entirely be equal to delta W, right? Delta Q will be entirely equal to delta W, and this is another type of process. Okay, so in none of the process the entire energy given was completely getting converted into work done. It will occur only when the processes are cyclic. And which type of processes? Something of this type. So in this process the curve is going like this and it is going like this, anti-clockwise pattern in this. So over here what I can say about work done is that initially if I am going from this point to this point, A to B, so initially the work done will be this area, right? And finally when I am coming from B to A, the work done will be this area, right? So over here since it is expansion, then there will be work done by the system, and over here since it is compression, there will be work done on the system. So positive work done minus negative work done, so overall the work done will be positive in nature, and hence is given that over here work done will be positive, and since work done is positive, that means energy was given to the system, right? Energy was given to the system, that was the reason the work was positive. Okay, so energy was given to the system. And over here what will occur, using the same explanation what I just did, over here we can say that work done is negative, since initially it was getting expanded but finally it got compressed. Okay, and initially the work will be this much and finally the work will be the amounting to, so the entire result will be that work done negative minus positive will amount to negative only, and hence work done will be negative, that will be equivalent to the area of this loop. And so over here what I can say is that work is being done on the system and energy is being released out of the system. Okay, so I suppose you have just understood the concept, the entire concept of the cyclic processes. Okay, now efficiency, what is the efficiency of a cyclic process? So obviously there are processes, then there must be the case of efficiency as well. Slowly we will be just going towards the heat engines portion, so over there also we will be talking about efficiency. So what is the efficiency? So suppose there we have a cyclic process and we have actually found out W amount of work out from it. We had to provide an energy Q and we just received W amount of work done. Clearly it should be that the amount of energy which you are providing, it should entirely go to the work done, right? Because there is no change in internal energy, but sometimes or the other your processes are not right, and some or the other losses you can encounter, right? So suppose you just had provided Q amount of energy but and had a work done of equivalent to W from that system. So that should be equal, the ratio should be equal to 1 and the efficiency should be 100%, but sometimes or the other it never happens. It never happens. You obviously know that the efficiency of any person even is not 100%. There can be some losses you can encounter. So the ratio of the work done you have made out from that cyclic process divided by the energy given by you will actually give you the value of cyclic process. Okay, fine sir. Now let's talk about those PV curves which I was telling you about. So what happens over here is, as you can see, this gamma value is near about 1.33, right? This value is around 1.4, this value is around 1.6. So as you are increasing the value of gamma, as you can see, or just consider it in the case of PV to the power alpha. So as you are increasing the value of alpha, your curve becomes more and more towards the vertical end, and as you are decreasing the value of alpha, it becomes more towards the horizontal end. So the horizontal portion and the vertical portion, what will be this process? This process will be the isobaric one, where the pressure is not changing. So this is actually representing a isobaric process, and over here what it will represent? It will represent an isochoric process where pressure is changing but volume is remaining constant. So as you move from isobaric to isochoric, your entire PV curves will be oriented, right? So if I talk about an isothermal process, so isothermal process will obviously be somewhere lying over here because the gamma of it is 1, PV to the power 1 is constant, right, in an isothermal process. So the curve will be somewhat aligned over here. Here the gamma's value is equal to 1, right? So just remember this case, okay, from isobaric to isochoric, how the curves are changing and what you should actually remember, okay. And here the significance has been dedicated in terms of mono, di and polyatomic molecules, okay. And the same expression is represented over here as well. So work done in the first process will obviously between 2 points will be more as compared to the work done by the other process, and work done in the fourth process obviously, that is of isochoric, will be equivalent to 0, okay. Good evening Divipal, how are you? Now so the same process, it was an expansion, now we have it in compression. So just go through it, it is just the same expression which I have just explained you, how in all the processes the PV curves will change and what will actually represent what, okay. So you might be given the PV curves and asked you about the processes which they are dedicating or which they are representing. So you should have a clear picture, you should always have a clear picture about what is the curve of PV and how processes will actually represented in the PV curve. So this thing should be pretty clear because it is asked quite extensively. Now let's solve this question. So it says that 105 calories of heat is required to raise the temperature of 3 moles of an ideal gas at constant pressure. Okay, remember this thing, constant pressure from 30 to 35 degrees centigrade. Okay. the amount of heat required in calories to raise the temperature of the gas, and the range now is from 60 to 65, now at constant volume. Okay, so initially it was at constant pressure, this increment in temperature. Now it is occurring at constant volume, and the increment is also now 5 degrees only. So what we need to find the ratio of them. Okay, no problem. So we need to find the ratio of heat energy supplied in first and the second process, and obviously the first one was isobaric, and the second one was isochoric. So I'll just replace it by V, right? Okay, perfect, sir. Now obviously in isochoric process, this entire energy will be equal to delta U, and over here in isobaric it will be equal to delta U plus delta W. But why to write that? What we can do is, I can just replace this delta Q by N into Cp into delta T, right? Where Cp is what? It is the molar heat capacity at constant pressure, and this is what the process is. And I can also replace this delta QV by NCV delta T, and Cv over here will actually justify the energy change required in an isochoric process. So as I can see, the temperature change over here, it was also 5 degrees centigrade, over here also it is 5 degrees centigrade, this will get cancelled, and number of moles are also getting cancelled. And what I am finally remaining up with is that the value is turning out to be Cp upon Cv, that is equal to 1.4, and this was actually asked in one of the exams of JEE Main only. So see, suppose it was a one-liner answer, and I suppose you all have understood. It is a very simple question, and the answer to it is only in a line. So the answer, yeah, so obviously it is equivalent to 1.4, and we are given with 105 calories. So this value is 105, and this will be 1.4. So just replace this 105 upon delta Q is equal to 1.4. What I can do is just remove this decimal. So this 7 will be equivalent to 115, this will be equal to 2, this 2 will go by 5, 15, 5 is 75. So delta Q is arriving to be 75 calories, and this is a very simple answer, and we got the real answer in a very quick span of time. So I suppose you just understood it. Hi Royal Vishnu, how are you? Okay, so if you just understood it, just tell me yaar, batao. If you understood the explanation, it was very easy. Okay. Now let's move ahead, and ये question बहुत अच्छा है. This question is very nice. इसमें calculus use होगा. So let's solve it. जल्दी solve करते हैं. क्या बोल रहा है ये? That for an ideal gas, if molar heat capacity varies as, so ये एक process दे दिया है एक ideal gas का कि C, the heat capacity, the molar heat capacity of that gas is changing as Cv plus 380 square. Then equation of that process is, we need to find the equation of that process. कैसे निकालें? ओके, इक्वेशन ऑफ द प्रोसेस वी टी वी स्क्वायर के टर्म्स में. चलो लेट्स ट्राई देखते हैं कैसे निकलता है. सो फर्स्ट ऑफ ऑल फॉर एनी प्रोसेस वी कैन एक्चुअली यूज दिस रिजल्ट, राइट? एंड सिंस आई सपोज ओवर हियर वील बी यूज्ड, there will be a need to use calculus, so I can just modify that formula of first law of thermodynamics by removing that delta and replacing dq over there. So dq will be equal to du plus dw, right? Yes sir, perfect. Now this dq can be represented as nc dt is equal ncv dt plus this dw can be represented as pdv, right? Yes sir, perfectly. Now what I can do is I can just replace this n dt and put it over here. So this c will turn out to be cv plus pdv divided by n dt, right? So can you just see a similarity between these two equations? I can see the similarity. This p dv upon dt, p by n dv by dt is actually representing this statement, right? It is actually representing this statement, and that can be replaced over here. So what I can finally deduce from both these equations is that p by n dv upon dt is actually representing 3a t square, right? But there is an issue. What the issue is that dt can be taken over here and integrated, but here a p is arising and p cannot be integrated with dv. So can you just replace this p as well? And they have clearly told that it is an ideal gas equation. So I think we can do it. How we can do it is that we very well know that PV is equal to nRT, and this is from an ideal gas equation, right? This is from an ideal gas equation. So what I can do is I can actually find the value of P by N. है ना. So P by N will be equal into RT by V, and this equation can be placed in this equation. This P by N can be replaced over here, so RT upon V will arrive over here, and then the entire equation will be in terms of either constants or variables, that too of V and T, right? So now let's just replace this P by N over here. So RT upon V can be replaced over here and you'll get the final answer. Let's see if we can do it. So RT upon V into dV by dt is equal to 380 square. Okay, so 1t will get cancelled by this dt can go over there, r can also go over there, so this will turn out to be dv by v is equal to 380 into dt, right? Perfect, right? I suppose you are getting this point. Now next what you need to do, you just need to differentiate it, and on differentiating it, what I can finally say is we are missing on something. Yes, r is missing. Okay, so dv upon v will be equal into natural log v, and 3a will come outside, 3a by r, so t dt will be equal to t square by 2, right? Yes sir. So the limits are not provided to us, we can actually just remain it like that only. You can add a constant since you are doing indefinite integration. So now what you can finally deduce from this result is, this is log of v with base e, right? So v can be written as this e, the base e will actually go over there, and ये पूरा जो term है उसकी power में चला जाएगा. So v will be equal to e to the power 3at square by 2r plus c, right? Yes sir, perfect. So do we have an option like that? We have an option over here, but ये इस तरीके से आ रहा है. Okay, just give me a moment, मैं इसको भी turn कर लूँगा. So what I'll do is, मैं इस चीज़ को, इस पूरे term को 3at square by 2r into e to the power c लिख सकता हूँ. I can do that, right? E to the power 3at square by 2r plus c. So e raised to the power 3at square by 2r into e raised to the power c. And उस वाला जो term है 3at square by 2r उसको इधर ले आऊँगा to the left side और इसमें एक माइनस साइन दे दूंगा. तो मुझे बताओ क्या मैं सही लिख रहा हूँ कि नहीं. इसको मैं लिखूंगा 3at square by 2r into e raised to the power c, and ये वाला term इधर आ जाएगा और वो माइनस में चला जाएगा. So v की वैल्यू आ जाएगी v into e raised to the power minus 3at square by 2r is equal to e raised to the power c, and c is obviously constant, so e raised to the power c will also be constant. So ये मेरा term है. क्या ये आंसर है? हाँ यार, ये बिल्कुल आंसर है. आई थिंक आप सभी को समझ में आया. यू गॉट द एंटायर आइडिया. मैंने कैसे इस चीज़ को सॉल्व किया, मुझे बस इतना पता था, एंड वहाँ से मैं बस कैलकुलस का यूज़ करते करते फाइनली इस रिजल्ट पे पहुँच गया. ठीक है, ओके. सो आई कैन रिक्वेस्ट यू सर दैट यू कैन अपलोड द वीडियो इन आवर चैनल. ओके, सो विष्णु, दीज वीडियोज़ आर ऑब्वियसली लाइव एंड यूट्यूब पे रहेंगे. यू कैन ऑब्वियसली वॉच देम एज मेनी टाइम्स एज यू वॉन्ट. ठीक है, एंड स्टार्टिंग में देखना आप इस वीडियो के, आई हैव जस्ट टोल्ड यू हाउ यू कैन एक्सेस द टेस्ट्स एज वेल ऐप पे जाके. सो ये जो आप कोड देख रहे हो ऊपर, इस कोड को आप नोट डाउन कर लो, एंड स्टार्टिंग में देखना, यू जस्ट हैव टू गो इन दैट ऐप. ओपन टेस्ट का सेक्शन मिलेगा आपको, वहाँ पे जाके इस कोड को आप लगाओगे तो आज के लेक्चर के आपको स्टैंडर्ड क्वेश्चंस मिल जाएंगे, और उन्हें आप देना, बिल्कुल देना, बिकॉज उससे आपको ज़्यादा बेनिफिट होगा, क्योंकि उस चीज़ से आपको एक एनालिसिस रिपोर्ट मिलेगी, आपका क्लियर पिक्चर पता चलेगा कि हैव यू बीन अंडरस्टैंडिंग इट और नॉट. ओके, नो वरी विष्णु, हैव मिस्ड टुडे, नॉट एन इशू यार. यू कैन जस्ट वॉच दिस लेक्चर अगेन एंड अगेन. ठीक है, जितनी बार आप देखना चाहो देख सकते हो. आपको कोई भी डाउट हो, यू कैन आस्क मी अप इन द नेक्स्ट लेक्चर एज वेल. ओके, नाउ ये था इस क्वेश्चन का एक्सप्रेशन. आई सपोज यू हैव जस्ट अंडरस्टूड इट, एंड यही राइट आंसर भी था. सो दिस वॉज ऑल्सो अ क्वेश्चन आस्क्ड इन वन ऑफ द JEE Main exam only. So now let's move ahead with the next question. So it says is n moles of an ideal gas undergoes a process A is to B. ठीक है, as shown in the figure, the maximum temperature of the gas during the process will be. Maximum temperature कब होगा ये पता करना है. So let's solve this maximum temperature of this case. But मैं आपको एक ट्रिक देता हूँ. There's a very good trick. इसका जो क्वेश्चन है, आप इस क्वेश्चन को ट्राई करना खुद से. What you just need to do, try creating an equation between P and V. ठीक है, P एंड V के बीच में एक इक्वेशन क्रिएट करना y इज इक्वल टू mx प्लस c के टाइप में. ठीक है, एंड आफ्टर दैट व्हाट यू नीड टू डू, दिस इज P, सो P entirely will be represented in terms of V only. ओके, नाउ उसके बाद इस P को आइडियल गैस इक्वेशन है, तो वो PV इक्वल्स टू nRT में उस P की जगह रख देना. ठीक है, सो देन द इक्वेशन विल टर्न आउट टू बी बिटवीन ओनली V एंड T. and then what you need to do, you just need to differentiate this temperature with respect to V, equate it with 0, जो भी वैल्यू आएगी उससे आपका आंसर मिल जाएगा। वो वैल्यू पता चल जाएगा जहां पे टेम्परेचर आपका मैक्सिमम होगा, मैक्सिमम टेम्परेचर। देखो जहां कभी भी आपको मैक्सिमम टेम्परेचर के केसेस मिले ना, वहां पे आपको डेरिवेटिव का यूज करना पड़ेगा, अप्लाई करना पड़ेगा आप डिफरेंशिएशन के प्रिंसिपल्स को, देन ओनली यू कैन फाइंड द वैल्यू ऑफ मैक्सिमम एंड मिनिमम। ठीक है, डिफरेंशिएशन इज वेरी हेल्पफुल इन सच केसेस। सो जैसे ही आपको वी एंड टी का एक्सप्रेशन मिलेगा, आप इस वी एंड टी वॉल्यूम और टेम्परेचर का एक्सप्रेशन मिलेगा, सो टेम्परेचर को डिफरेंशिएट करना विद रिस्पेक्ट टू वॉल्यूम, सो देयर यू विल बी गेटिंग द वैल्यूज ऑफ वॉल्यूम जहां पे टेम्परेचर मैक्सिमम होगा। ठीक है, एंड वो जो वॉल्यूम की एक्सप्रेशन आएगा, दैट वॉल्यूम विल टर्न आउट टू बी 3v0/2। ठीक है, एंड इस वॉल्यूम को जो यहाँ पे आपने P को V के टर्म्स में एक्सप्रेस किया, उसमें डालोगे तो प्रेशर का रिलेशन आ जाएगा 3p0/2। एंड अब ये आ गया तो टेम्परेचर तो पता चल ही जाएगा। टेम्परेचर क्या है, P0 PV इज इक्वल टू nRT। सो मैक्सिमम के लिए, फॉर दिस टू बी मैक्सिमम, this P should be equal to 3p0/2 into 3v0/2, and obviously nR will be multiplied over here. So finally the result will be equivalent to, T max will arise that 9p0v0 upon 4nR, and this is your exact answer. But I want you all to actually try this result. ये जो result हमने पता किया, आप try करना, P और V का एक relation बनाना बहुत easy है, it's not a big deal। आप इसमें straight line के concept use करके एक equation बना सकते हो, और फिर ये बनाने के बाद PV equal to nRT में वो P की value डालना, so आपके पास volume और temperature के बीच में relation आ जाएगा, और फिर derivative use करना है और आपका ये आंसर आ जाएगा। ठीक है, and इस statement के साथ let's start our discussion about second law of thermodynamics. So what is second law of thermodynamics? Second law of thermodynamics में बहुत सिंपल सा स्टेटमेंट है, एंड इट जस्ट सेज दैट, यहाँ पे दो स्टेटमेंट्स है, केल्विन प्लैंक के और क्लॉसियस के, एंड इन दोनों का एक ही मतलब है कि हीट का जो फ्लो होता है वो हमेशा हाई टेम्परेचर टू लोअर टेम्परेचर होता है, बट वेन एवर यू वॉन्ट द हीट टू फ्लो फ्रॉम लोअर टू हायर, फ्रॉम अ कोल्ड रिजर्वोयर टू हायर रिजर्वोयर, और heated reservoirs तक पहुंचाना आपको cold reservoir से energy, then you will obviously have to go against the natural flow of heat, then you obviously will have to work done। ठीक है, आपको वर्क करना पड़ेगा जब कभी भी आपको एनर्जी एक लेसर टेम्परेचर रीजन से हायर टेम्परेचर रीजन में ले जाना है तो। And no process is possible whose sole result is the absorption of heat from a reservoir and the complete conversion of heat into work. First one, मतलब efficiency कभी भी आपकी 100% नहीं हो सकती. This is first statement. The second one is no process is possible whose sole result is the transfer of heat from a colder object to a hotter object. Obviously कोई process possible नहीं है. अगर आपको करवाना है then you will have to do some work. As in the case of a refrigerator or a fridge. So fridge or refrigerators, do they work on their own? You obviously have to provide them with energy, right? In the form of electrical power. So आपको energy provide करनी पड़ती है, work done करना पड़ता है, तभी जब compressor work करता है तभी वो अंदर के एक region को जहाँ पे वो already cold है वहाँ से और energy absorb करके बाहर hot and humid climate में देता है, ठीक है? So this is what this is all about. Now let's talk about heat engines. So heat engines कैसे work करते हैं? हीट इंजन्स का मेन वर्क ये है कि जैसे हमारी गाड़ियों के इंजन, सो हमारी बाइक्स के इंजन, हमारे कार्स के इंजन, सो व्हाट इज़ देयर वर्क? वो एनर्जी लेंगे कहीं से, ठीक है, एंड से सपोज एक हॉट रिजर्वॉयर है जो कि उन्हें एनर्जी प्रोवाइड कर रहा है Q1, एंड इस हॉट रिजर्वॉयर से उन्हें एनर्जी मिली, यहाँ पे इस एनर्जी को अब्जॉर्ब करके उन्होंने कुछ वर्क किया. They obviously have to do some work, right? Engines' sole responsibility is to do work. The car's engine's sole responsibility is to make the piston move. Then only a car can travel in forward direction. So they will obviously do work by absorbing some amount of energy, but some amount of energy is released obviously. Entire energy cannot be converted into work. Okay? So the question over here will not be asked about how an engine is working. That is some high level physics which you will be discussing, और आप engineering में जाओगे तो then you will be talking or discussing about how an engine works. Over here we just need to dial in that thermodynamics portion over here in engines. So we will have to talk about its efficiency, and its efficiency is obviously कि for what reason you have created an engine. You have created an engine to exert or impart some work out of, or to extract some work out of it, right? So the efficiency will obviously have the numerator as the amount of work which you have extracted from it divided by the energy which you are providing it. So suppose you're providing 100 joules of energy and you can just extract only 5 joules of it, then the efficiency is very less obviously. If you're studying for 20 hours and you can just focus your mind for half an hour, then your efficiency is obviously less. You need to work on that, my brother. But an engine is good when you are actually providing 100 joules of energy and around 60 or 70 joules of energy is work you are actually able to produce, then your efficiency is good. You can obviously never have 100% efficiency. Just like the case with you, if you study for 10 hours, it's highly impossible that for the entire 10 hours you will have that focused mind. Obviously you will have your distractions, right? आपको distractions होंगे, and the main task is just to increase your efficiency. आपको यही करना है, and this goes everywhere, wherever you go, if you work, if you study, whatever you do in your life, it's all about efficiency, how efficient you are, and you need to work on that. And for efficiency to work on, you need to have a focused mind, you need to have a very planned structure. You cannot just go random everywhere, okay? So a heat engine actually is very much relatable with us as well, okay? So as you can see, the efficiency is, as I told you, the work which you have extracted divided by the energy which you have provided. And obviously I can actually use conservation of energy over here. So Q1 will be the initial energy which has been provided. It will obviously be equal to the work done and the energy which goes to the sink. This is also known as the sink, okay, and this is also known as the source. So using this method I can actually relate this W as Q1 minus Q2 and can be replaced over here. So it will turn out to be 1 minus Q2 upon Q1, okay. So this was all about heat engine. Now if I talk about refrigerators, okay, Ridhima, how are you? Vishnu, fourth option of the previous question. Yes, you are absolutely correct, Vishnu, absolutely correct, that was the answer. Now if I talk about a refrigerator, so in a refrigerator what occurs is, if you have obviously seen a refrigerator and obviously you have seen an air conditioner as well. So what happens in an air conditioner is that there is a colder region. Obviously just imagine summers, you have your house air conditioned with an AC, and obviously outside the temperature is around 38-40 degrees centigrade and inside it's peacefully around 24-26, right? So you have a colder region inside your house and hotter region outside, and still what you want is you never switch off that AC, you want it to be running, and the reason is because the temperature can rise anytime, okay, whenever the AC is just switched off. So that AC's function is to extract more amount of energy or more amount of heat as it is getting generated in the cold reservoir, that is your house, and remove it to the outside world. And this is obviously against the natural flow of heat energy, because heat energy naturally flows from a hotter region to a colder region. So for that what you need to do is you need to impart some work, you need to do some work on that engine or on that refrigerator. You need to provide electricity to the compressors, and that compressors will do work, right? And those compressors obviously do work on a gas, and that gas actually becomes colder, and this is the reason why your house is colder and the outside region is still hotter, okay. So over here in a refrigerator what occurs is you need to do some work in extracting Q2 amount of energy, okay. You need to do some work in extracting Q2 amount of energy, and obviously using conservation laws, conservation of energy, what I can see is that Q1 obviously will be equal to Q2 plus W. Okay, this is the energy imparted or given to the outside surroundings or the hot reservoir, okay. So the efficiency over here will be that how much amount of energy that refrigerator was capable enough to extract from that cold reservoir with the help of W amount of work given by me, okay. So Q2 upon W, that is how much amount of energy, कितनी ज़्यादा energy उसने absorb करने की उसमें capability है एक room से, और उस एनर्जी को ऑब्जॉर्ब करने के लिए मुझे कितना वर्क करना पड़ रहा है. और यहीं पे तो दैट दिस इज हाउ दोस 3 स्टार 4 स्टार्स एंड 5 स्टार रेटिंग्स ऑफ रेफ्रिजरेटर्स और एसीज आर देयर, कि उसकी एफिशिएंसी कितनी है, मतलब कितनी ज़्यादा एनर्जी एफिशिएंट है. 100 जूल निकालने के लिए क्या मुझे 100 जूल ऑफ वर्क करना पड़ रहा है या मुझे 50 या 40 जूल ऑफ वर्क करना पड़ रहा है, ओके. सो यहाँ पे एफिशिएंसी आती है. सो W अपॉन Q2 अपॉन W will actually give you the value of efficiency in case of reservoir, and obviously you can replace this W by Q1 minus Q2, which depending on whatever answer or whatever value has been given to you. So understand this concept very clearly, that what it is all about. Now if I talk about a Carnot engine, so Carnot engine is a specific entity, is a specific figure, although this engine is not much in use, but you actually need to understand it, because normal day engine में भी जो भी 4 stroke 5 stroke होते हैं उसमें भी there is a concept of this isothermal change, isothermal expansion and adiabatic expansion. So I'll just give you a glimpse of it. So what happens in a Carnot engine is it is a cyclic process. First of all, ओके, एक साइक्लिक प्रोसेस होता है 4 प्रोसेसेस के कॉम्बिनेशन से, एंड उस साइक्लिक प्रोसेस से एक वर्क एक्सट्रैक्ट होता है जो कि ऑब्वियसली पीवी कर्व में यू हैव जस्ट अंडरस्टूड एरिया ऑफ द कर्व होगा, ठीक है. दिस एरिया, एंटायर एरिया ऑफ दिस लूप विल एक्चुअली गिव यू द वर्क व्हिच इज गेटिंग एक्सट्रैक्टेड फ्रॉम दिस प्रोसेस, एंड ये जो वर्क डन है ना, दैट विल बी द एक्चुअल आउटपुट. ओके, एंड यहाँ पे एनर्जी आप दो जगह देते हो, दो नहीं, बेसिकली एक ही जगह देते हो. यहाँ पे इनिशियली यू प्रोवाइड सम एनर्जी Q1 एंड देन आफ्टर दैट यू डोंट हैव टू सफाइज इट विद एनर्जी. आफ्टर दैट एनर्जी कम्स आउट ऑफ थ्रू सिंक, एंड फाइनली जो वर्क आउटपुट रहेगा इस पूरी साइक्लिक प्रोसेस में, वर्क आउटपुट डिवाइडेड बाय दिस Q1 विल एक्चुअली गिव यू द वैल्यू ऑफ योर एफिशिएंसी. सो व्हाट हैपेंस ओवर हियर इज initially it is a, as you can see over here, initially it is an isothermal expansion. Okay, it is an isothermal expansion. So P1 V1 T1 will actually isothermally expand. The gas expands, and during that expansion you have to provide some energy, और isothermal expansion होता है, ठीक है. Then उसके बाद what happens is there is an adiabatic expansion जिसमें we are not providing any energy, from the surroundings, and the gas expands on its own. It expands on its own with the amount of work done. Adiabatic में क्या होता है, जितने भी internal energy होती है वो convert होती है work done में. Okay, तो यहाँ पे internal energy decrease होगी और work done होगा. Then after that what occurs is there occurs isothermal compression of the gas. Okay, isothermal compression of the gas होता है, and यहाँ पे energy system से बाहर निकाली जाती है. ओके, सिस्टम से बाहर एनर्जी निकलती है, एंड यहाँ पे आइसोथर्मल कंप्रेशन होने के बाद उसके बाद होता है एडियाबैटिक कंप्रेशन, एंड फाइनली वो अपने ओरिजिनल स्टेट पे आ जाता है, ठीक है. सो द फर्स्ट वन इज ऑब्वियसली आइसोथर्मल एक्सपेंशन. Then over here it will be, in this process it will be adiabatic expansion, over here it will be isothermal compression, and over here it will be adiabatic compression, and इसके करने से finally the final state and the initial state becomes to zero, and this is one cycle in which that engine operates, and इस cycle में जो work output होता है that is actually the area of this loop, and the area of this loop divided by this Q1 energy will actually give you the value of efficiency of a Carnot engine. Okay, so W, that is the work output, the work of this entire loop divided by the amount of energy. So amount of energy which you have given, this is in the initial process, that is during isothermal expansion only. This is actually equivalent to the efficiency. Now you are initially providing some energy, and finally some energy is coming out of it, that is Q2. So obviously Q1 will be equivalent to the work output plus Q2. So W can be replaced by Q1 minus Q2, and also this Q1 minus Q2, using those expressions of isothermal expansion compression, you can finally decode is that this ratio of Q2 upon Q1 is actually equal to this ratio of T2 upon T1. So if you are knowing the temperature, of the sink or the colder region, so T2 over here is what? The temperature of sink, that is at the colder region, and T1 on the other hand is what? It is the temperature of source, that is the hotter region. Okay, and 1 minus T2 upon T1 will actually give you the value of the efficiency of the Carnot engine. Now let's solve a question. Upon solving this question, we can very well understand how efficiency of any engine is defined. So in this question, a Carnot engine working between 300 Kelvin and 600 Kelvin. So what is 300 Kelvin over here? This is obviously the temperature of sink, and 600 Kelvin is obviously the temperature of source. Okay, has a work output of 800 joule per cycle. So out of every cycle, this much amount of work can be extracted from that Carnot engine. The amount of heat generated supplied to system from the source in each cycle is. Now what will be the amount of heat which is being supplied to that system? So now you very well know that the efficiency is obviously equal to the amount of work which is being extracted, divided by how much amount of energy you have given, right? And the efficiency, there are two formulas, there are two basic formulas for actually finding the efficiency. One of them is actually 1 minus Q1 upon Q2, Q2 upon Q1, where Q2 is the energy which is getting extracted out and Q1 is the energy which has been given, and this can obviously written as 1 minus T2 upon T1, where T2 is obviously the temperature of the sink and T1 is obviously the temperature of the source. So I can find the value of efficiency using this approach, right? The temperatures have been given to me. So what will be the value? It will be 1 minus 300 upon 600, and this will amount to 2. So 1 minus 1 by 2. So efficiency is finally turning out to be 1 by 2. Efficiency is turning out to be 1 by 2. So 1 by 2 can be written over here, and the work output we very well know it is given as 800 joule per cycle. So Q1 will be how much? You can now very well tell it yourself as well. 1 by 2 will be equal to 800 divided by Q1. So Q1 is 1600 joules, and this is your correct answer. This is your correct answer. Now I suppose you all have understood the result of a Carnot engine. So all these engines, heat engine, refrigeration, the questions of efficiency are asked quite extensively. Most of the time the questions are about these efficiency only, and the entire thing has been given out to you that this is the energy, this is the work done. Now let's calculate the efficiency, or the efficiency is given in such a manner. What is the temperature of sink, what is the temperature of source? To do remember those formulas, okay? And we have just discussed all the concepts of thermodynamics, all the important concepts of thermodynamics, as well as the important elements in KTG as well, okay? For login, OTP is not coming. Okay, hi Saurav, how are you? Vishnu, OTP will arise. Just try and put that airplane mode in your phone. Even I don't. कभी कभी मेरे साथ भी हो जाता है, OTP नहीं आता है. So what I do is I just switch on that airplane mode, and उसके बाद network वापस से revamp होके आ जाता है. ठीक है? So this will be the end of this lecture, and as I told you, you have to download our app. आप ऐप पे जाइए, ऐप पे आप बहुत सारे क्वेश्चंस प्रैक्टिस कर सकते हैं, देन अपने टेस्ट भी क्रिएट कर सकते हैं. ऐप दोनों ही प्लेटफॉर्म्स पे, प्ले स्टोर में भी है, ऐप स्टोर में भी है. हमारा नेक्स्ट सेशन होगा SHM का, होगा बहुत ही इंटरेस्टिंग सेशन होगा, एंड द टाइम इज ऑब्वियसली 5 PM. ये डेट याद कर लो, डेट इज 8th of Feb. I'll be taking it, and जाने से पहले I'll be again giving you a glimpse of our application. So just see over here, यहाँ पे आप ऐप पे जैसे ही जाओगे, देखो यहाँ पे आपको ये आपका डैशबोर्ड, आपको प्रोफाइल सेव करनी है, एंड यू वेरी वेल नो हाउ टू डू इट. जस्ट एंटर द डिटेल्स. क्लास 12+ पे जाना है बाइलिंगुअल में, एंड उसके बाद आपको यहाँ पे ओपन टेस्ट में जाके टेस्ट आईडी देना है, और टेस्ट आईडी यहाँ पे थ्रू आउट दिस लेक्चर हैज़ बीन मेंशन्ड इन फ्रंट ऑफ यू. ठीक है, ये रही वो आपकी टेस्ट आईडी. ठीक है, ये जो आप देख रहे हो यहाँ पे, दिस इज योर टेस्ट आईडी. इस टेस्ट आईडी को आपको कॉपी करना है और यहाँ पे पेस्ट कर देना है, एंड अकॉर्डिंगली आपका टेस्ट ओपन हो पाएगा. एंड टेस्ट आप दीजिए, बहुत अच्छी तरीके से दीजिएगा टेस्ट. आफ्टर गिविंग टेस्ट, this kind of a report card you will be publishing in front of you, and this will obviously, the result over here is very bad, and I suppose आप सभी का result इससे बहुत अच्छा होगा. But the best part about this is there will be a peer analysis report. They will obviously tell you about your efficiency as well, how much time you took, and difficulty wise questions, were you capable enough to solve these questions or not, and identify a strong and weak area. So this is a very comprehensive report, and I seriously suppose this kind of feature would have been there when I was also preparing, but it is for you guys, and you should definitely try for it. Okay. Now okay, how to access code? These are the codes, and if you can see, these are the codes for previous sessions as well. So suppose if you want the test of kinematics, okay, then you can just copy down this code. If you want the test of laws of motion, of work, power, energy, rotational, kinetic theory of gases and thermodynamics, this is today's lecture. After rotational motion also, fluid mechanics and whatnot, all those lectures, we'll be giving you codes accordingly. In the next session, we'll be giving you the codes of the other remaining crash course and their test as well. But for the timing, I want you all to actually give these 5 tests and just analyze yourself how well you have performed. Okay, so we'll be meeting in the next lecture, and obviously the dates, you all know the dates are 8th of Feb, sharp 5 PM, and we'll be meeting over here only. Okay, so till that time, do watch these sessions. For any doubt, you can actually ask me in the next session. The next session will be all about simple harmonic motion. Okay, till then, it will be nice to meet you again the same time, same over here only. जब तक मिलते हैं, पढ़ते रहो यार. All the best for your studies and stay safe. Okay, bye bye.